Okay, so again, welcome to this workshop. So we're going to go through a lot of practical examples how to use cloud computing, how to do global scale analysis with componentized code or even no coding. And so the workshop notebook, for those of you who are not familiar with Python, notebook basically is like, think about a Microsoft Word document. You are writing text, but notebook is where you write the code and then execute the source code. And even if you don't have any programming background, trust me, you'll be fine today. And the notebook is available here. If you go to the website and then under workshops, scroll down to the end, IGIC 2024. And you'll be interested in previous workshop. I also have lots of those in there. And I think today is the longest one in the workshop. So you have all the materials for you to use. So if you click IGIC 2024, here, this is a notebook. You can scroll down to see the content. On the right here is the table of contents. So basically, this website renders the notebook for you to see. You don't see any result. It's just the text and the source code. So we're going to run the source code. You're going to see the result, and then you can play with it. And there are two ways you can follow through. You can either use there's a button here, open in Collab. So if you want, you can right-click and then open the link in new tab. Then it should take you to the Google Colab. So Google Colab is a cloud computing environment by Google. It has a free version. It also has a paid version. So we're just going to use the free version. And let me zoom in a little bit. Oh, it's too small. And then, so from this notebook, like I said, it's a very long document. First, I'm going to quickly go through some of the shortcuts and the buttons that you might want to use. Upper left corner here, there's a kind of like the hamburger sign. This one is the table of contents. So later on, sometime if you need to go back, you can open the table of contents and just click to navigate through each section. And also there's on the lower left corner here, there's a file icon. So this is the one if you want to save something. Keep in mind, this is all temporary environment. Once you close it, it's gone. So you can think about it's a virtual computer. We're going to create it, and don't close the tab. If you accidentally close, don't panic. It's fine. You can open again, but you just need to reinstall the packages and then you just run it. So it might take a couple of seconds. But if it happens, if you cannot follow, just raise your hand. I can help you out. And so here it allows you to connect to your Google Drive. If you want to, you can certainly. So this is just a temporary computer, but if you need to save files, you can do that. I will show you later. And pretty much these are only the two buttons you might need to familiar. And also here have a code and text. So those are the two buttons that if you want to create a new code block to write code, and then you can do it. And if you want to write some text, you can do that as well. But always keep in mind, this is just a temporary one. If you want, you can click this button to copy to your Google Drive. In that way, the file is saved to Google Drive. So it's always available in your Google Drive if you want to. So for example, I can just copy to Google Drive. So in that way, later when you make changes, the changes will still be available in your Google Drive. And you're going to have the title here, blah, blah, copy of something. I can just remove it if you want to. And this file is saved under your Google Drive. So if you want to check it, you can certainly do. Let me see if I can. Also, there's an icon here, save in Google Drive. And there's a menu here, file, locate in Drive. So this is going to show you where the file is being saved. So if you click this link, it should take you to your Google Drive. Somewhere here under it says so Collab Notebooks. Under your Google Drive, and then there should be a new directory called Collab Notebooks. It's going to save in here. I have a bunch of other files, but if you did the new, you just be starting using this, you should have only one file under this directory. So later, you can go back to the Google Drive to check it if you need it. So, and then, so this workshop, we're going to cover three major parts. The first part is about how to access the data, how to visualize the data, how to search the data. Kind of like how to search the movie, how to watch the movie. The second part is how to do some analytics. For example, how to figure out how long does the main character appear in that movie? When does it appear? And are there any other characters? Or how to extract the character from the movie? how do you remove all the background, something like that. So similarly in geospatial, we can do analysis, we can figure out some statistics to calculate, for example, what's the land cover composition in a certain area or at a global scale, what's the agricultural area, what's the forest, or any changes throughout the years, 20, 30 decades, doesn't matter. So just to keep in mind now, with this cloud computing, you can think about science questions without worrying about the location and the time, because everything is universal. If you develop the algorithm that can be applicable to other areas, then it's going to have more impact, because in the cloud computing environment, all the data are freely accessible. Most data at the global scale, and you have decades of data they can utilize. So you don't have to worry about specific location, specific time, as long as your algorithm is generalized enough, they can handle all kind of location. And lastly, we want to do some, for example, more advanced, how to do some remote sensing image classification, how to classify, how to extract land use and land cover change. And if we have time, we're also going to show you how to create interactive web app, so other people can access your stuff. If you generate something, if you write publications or whatever, at the end, people, if you're doing geospatial, we want to see the map, we want to see the data. How do you make things basically available? So the last one would be like, yeah, you have watched a lot of movies, you like it, and eventually you're going to become an actor, a director, direct a movie, and you need to make it available for people to watch. So how do you actually make that happen? So it's also available. So people don't need to know the code, don't need to know coding. They can also watch your movie, watch the data products, watch your algorithm. They can run through that. So we're going to go through the whole process from accessing the data, visualize the data, analyze the data, and at the end, make the data accessible to the public, just using a browser without using any desktop software. And so here is kind of the introduction about Google Sensing. For those of you who are totally new, Google Sensing, you can think about, it has three major components. So the data catalog, so think about the movie database there. And then it has some analytical functionality for you to analyze the movie, analyze the geospatial data. It also has something that allows you to turn things into a web app. So basically the data catalog, the algorithm, and also the app, the web app. So three major components. You can learn more about that. So Google Sensing is free for research and education, and also non-profit. Even if you're working for the government, you can play with it using your personal account, and then if really the government wants to adopt that, then you might need to contact Google for a commercial license. But nowadays, most of the federal agencies, NASA, USGS, EPA, they all have contract with Google that they can use those also for commercial applications. And so I recommend you using a personal Gmail account to sign up. If you're coming from university, if you use your university email to sign up, unless you have done that before, you can use Python successfully. I would not recommend, because it's free, but you need to enter a credit card to be charged. So everything is going to do is free, but you still need to enter the credit card in case, because everything is tied to the Google Cloud project. The cloud project can be used for Google Sensing, but it can also be used in all other cloud services. So if you play around and then you accidentally use some of the services, it's going to charge you money. So the university nowadays used to be allowed the students to create the cloud project themselves. Now they stopped that. So most likely you won't be able to create a cloud project, because the university doesn't allow that anymore, because they don't want to pay the unexpected bill that you use a lot of expensive stuff. So just want you to be aware, if later you are authenticating your account, but using EDU, you might run into problems. So you can sign up using your personal email. It's pretty straightforward. And so Google Sensing has a huge data catalog. So this is the power of cloud computing, is that you don't have to download data. So imagine you have the entire movie database for free for you to watch. You don't need to pay anything. People will like it. So this is all the geospatial data, satellite data, land use, land cover, weather, climate, you name it. If you're using remote sensing, you have been using geospatial data, you will find some data that you have used before. It's already there. And you might have been downloading data left and right from USGS, from NASA, from your government data portals, but now you don't have to. You can just pull the data, you can watch it. So basically you can see the data within a couple of seconds. And it can be global scale, it can be terabyte data. So right now Google Sensing has over 100 petabyte. 1 petabyte is 1,000 terabyte. So it's 100,000 terabyte. and nobody can really handle this kind of a data volume except big techs. I don't think the government, even NASA, has more data than this, but most of data are not everything is in the cloud yet. So it makes it really accessible, and everything is synchronized. So basically, streamlined, and you don't have to worry about the projection. You don't have to use how to reproject from this to that. Everything is automatically reproject to the same map. So you can load the data on the same map, and multiple source, multiple resolution, multiple time periods, all on the same map very, very easily. We'll show you how to do that later, but this is just showing you the big powers, the data catalog, and then the computation, and then the visualization. So those are the three major components of cloud computing. So besides the official Google Engine data catalog, that one is the official one. There's another one called Awesome GE Community Data Catalog. I believe I have the link here. If you click it, you should be able to take you to the community data catalog. So this one is more like the community maintained. So if you have some data, for example, not available in the official data catalog, you can submit your pull request from this GitHub and ask them to ingest the data to the data catalog. So keep it in mind that it has a huge data catalog, and the data is different from the data on your local computer. So you might have downloaded, for example, a landscape imagery on your computer. Second one is just a imagery on your local computer. It's not optimized for cloud computing. Just like you might have a movie saved on your computer or some MP4. It's different from the movie on Netflix. Although it's the same thing as the movie, but the protocol, how they store the data, how to make it accessible to other people and stream the data very, very quickly is different. So the data need to be uploaded to the cloud, and they need to be optimized for cloud computing. So they are two very different things. And this is also called the cloud object or the server side object. On your local computer, it's called the client side, and your computation is going to be much slower. And the cloud is going to be faster, but it's not just a file. Just imagine it's not just a single file on the computer and it just streams. There are a lot of things to make it faster. So it needs to be optimized for data processing. So if you find any data you want to use, it's not available in the data catalog, you can upload to your own account for your personal use. For example, you might have or require some UAV imagery for your project. You can upload to your own account. Nobody can access it. But if you produce some data products or other people have produced some data products, it's very useful for other people. You can submit a request here to ask them to adopt the data set, and then it upload the data set and then optimize, then it becomes a cloud data set. Then everyone can use. So it's different ways of doing that. And so for today, we're mostly just going to use the data from the public data catalog from Google Engine. Is already enough for us to play with. 100 petabyte. Yes? There's no cloud. There's no Google Engine. So it's different. Even if it's saved on Google Drive, it's stored in the cloud, but it's not optimized for cloud computing. It's just data storage. So in order to be used by Google Engine, you need to upload to your account, also called the cloud project, and then ingest into Google Engine, and then it's optimized for cloud computing. So basically, there's a two-step process of doing that. And so next, let's quickly talk about the API. So API stands for Application Programming Interface. So basically, it's allow you to access the functionality of Google Engine. So you have the data, we want to do some analysis, you need basically some interface to interact with the data. So we want to call a lot of functions. So Google Engine has two APIs, the JavaScript API, the Python API. They are pretty much similar, but they certainly have some pros and cons. And they originally, when Google Engine started releasing Google Engine, mostly JavaScript. So Google Engine was officially released in 2010. So it's almost 14 years now, but they didn't release it to public until 2015, I think 2016. So it's 7 or 8 years, but it's become the most popular cloud computing platforms now. And the API, you can think about here, they have the JavaScript API, they have the Python API. Those are more like high-level API, but beneath they have the so-called REST API. So all the JavaScript code and Python code is being converted to the so-called REST API, and then send the REST API to the server to do computation. So it doesn't matter what you are using JavaScript API, Python, you're not using it directly. It's being converted to another language, and then kind of like computer, you see all the files, see other stuff. Under the hood is just 1 and 0. Computer only recognize 1 and 0. So it's kind of like that, and then interact with the server to do computation. And I would like to point out here the reason why so many people use Google Sending, besides the data catalog, the other advantage is computation. It's very powerful, it's very fast, you can do global scale. So for example, you're trying to map, like they say, extract the water for Indiana. Just a couple lines of code, you can extract that, and you can export the result if you want to, rather than you have to download the data for the whole state. And the reason it's so fast is because, just like you here, right, we have so many chairs, right? So when imagine each of you sit on one chair. If I need to do something, I ask each of you to do a little piece. So for example, I divided the entire Indiana into smaller pieces. Each of you handle one piece. And you can do it simultaneously. I don't have to do it all at once. I just ask you, you focus on Michigan City, you focus on the other city, and once you finish, you send the result back, so I can aggregate. And it has tens of thousands of servers on the Google Cloud data center. And also keep in mind, when you're doing the computation, it's different from a desktop, right? You load an imagery, you run the computation. It's going to run the computation on the entire image. So if you have a 1 gigabyte imagery, it's going to, your ArcGIS or MV, whatever, it's going to run on 1 gigabyte. But cloud computing is different. It depends on the zoom level. It's not depends on the file size. So this is a very important fact that you need to understand. It's not running on the 1 gigabyte imagery. So when you zoom, you see the global imagery, it's very close resolution. The imagery might be only 10 megabyte. And 10 megabyte, I subdivided into 100 pieces. Each of you handle only 0.1 megabyte. And that's why it's super fast. So you just send me the result in seconds, maybe less than 1 second. And then I show you the map. If you zoom in, the resolution becomes higher, but the area becomes smaller. So it's still going to be 10 megabyte. And you keep zooming in, keep smaller, so the file size is actually very tiny. And this is why the computation is run all on real time. You can see the result very, very quickly. Rather than if you're using desktop, if you have a 1 gigabyte imagery, it's computing on 1 gigabyte imagery. If you don't have enough computing memory, it's going to throw errors. So this is how all the cloud computing now is being done, is run the computation in real time. It's very fast because it's only doing a tiny portion of the imagery. Large area, post resolution. Smaller area, higher resolution. And the file size is not going to be original. Unless when you are saying that I want to export the data, I want to expect the 1 meter resolution, then it's going to be slow because it does need to run on the entire imagery. So unless you really need the original result, sometimes you just want to see how it looks. You don't need to compute the 1 meter, the entire imagery, right? Just like you're watching a movie, 4K. So the file might be 20 gigabyte. But if you just want to go to the highlight, you just drag through, fast forward, and then see the imagery, right? You don't need the entire all the scenes. So you just look at the one you want, and then you get the result. Kind of like the same idea for this cloud computing. So once you understand that, you can like do scalable computing. So these are API that can help you do the computation. JavaScript, Python, it doesn't matter. So to me, language is just a language. More important is your thinking, how to design, how to turn this one into something that the computer can understand. So you can use JavaScript. If you're familiar with that, you can use Python. But I'm not good at JavaScript. That's why I develop package to do it using Python, make it easy. And most of the things you can do just within a couple lines of code or 1 line of code. JavaScript might need hundreds of lines of code. So for those of you who already use JavaScript, now you can, in your mind, when we're running through the example, you can think about how do I do this in JavaScript? How many lines of code I need to write? To, for example, add a simple color bar, something like that. In Python, it's super easy because I've done the coding. You can just click a button, then you can get things done easily. And you can also, for Python, you can have a different IDE. IDE basically your editor used to write code. You can use Visual Studio Code, you can use Google Colab, you can use Jupyter Lab. So there are a lot more options for you to choose from. Kind of like when you're trying to write something, write a paper, you have many choices. You can Microsoft Word document, Office 365, Google Docs, or Notepad, whatever you like, but you have a lot of options. JavaScript, you're logged into it. You can only use Microsoft Word document. You cannot use anything else. and it's logged into one specific editor. Also, you can integrate with desktop.js, you can use ArcGIS, you can use QGIS, you can connect to the server. So in that way, you can do cloud computing, you can get the result and then display using the desktop software. You can also do deep learning if you want to. So there are a lot of advantages of using Python. But like I said, it doesn't matter. If you an expert in JavaScript, you can continue to use that. But for me, I use both of them, mostly Python, but sometimes I do use JavaScript because it might be easier. Okay. And so next, let me quickly talk about GMap. So GMap basically is Google's engine. Map basically is trying to help visualize the data. So this is the package I created in right after pandemic, April 2020. So it's 4 years now. And so initially I was teaching my students how to use Google's engine, and the Python support was really bad at the time. There's pretty much no support, and it's very, very difficult to actually to visualize the data. And as I mentioned, you can think about the cloud computing. Google's engine has two components, the computation and the visualization. So it has the data catalog. You want to run analysis on the data, and once you finish the computation, you want to visualize the result, right? So for example, you do land cover classification on a landscape imagery. How do we actually see the map? How see the imagery? So in the past for Python, you can print out a thumbnail, like a small low resolution thumbnail. That's it. You cannot see the imagery interactively. So GMap is basically trying to solve that, to bridge the gap. Is allows you to see the data interactively, zoom in, you can zoom out, you can inspect. So there are lots of tools that can help you visualize the data. So I released it 4 years ago, and I pretty much adding new features every week. Not the past year, but in the early years, I did a lot of development and then improved it. And so after 3 years, last year, it was officially adopted by Google. So now, if you want to use Google's engine, you want to use Python, then GMap is the official one that's being supported by them. And by Google, the Earth engine team only support a core functionality. So GMap has a lot more. Basically, but they support the core, it's very stable, and it's also available in Google Colab. So later we're going to see this one here. You actually don't need to install anything. You can just use it. But there are some additional dependencies that that we need for this workshop, and I will show you later. So, and again, you can check out the website. There are lots of tutorials from here. And what we're going to cover today, I would say maybe cover 10, 15%, or maybe 20% of what GMap can do. There's actually a lot more in here. And if you want, you can take a look at the bottom here, notebooks. If you, whoops, let me see if you can scroll up. It doesn't. Interesting. Yeah, you should be able to scroll on the lower left corner here. There are hundreds of notebooks available. And so each notebook basically covers one feature about GMap. Also on the left side here, if you click the book, the second item after the home, I published a book last summer, about how to use Google's engine. So what we're going to cover today actually use some of those, but not all of them. So after the workshop, if you think you have mastered all of them, you want to learn more, then you can check out the notebook. It's all open access. Also, all the source code, you can just open it, you can run it. And so here, similarly, you can, for example, open in Colab, and then you can just run through that. You can test it, you can change the area, you can change the time, so you can play with a lot of things. And let me go back here. So next, let's get started. So I will give you some intro, some background. So hopefully now you understand. Probably you haven't been sold yet that you want to use it, but once you start, put your hands on, then you will really appreciate the power of cloud computing, of streaming data using a browser. So and so I'm gonna show you how to use GMap in Google Colab yet. Then I'm gonna switch to my local computer. If you want to set it up locally, it's up to you. And so first thing first, I want to suggest that you switch to the light mode, because some Google Colab supported light mode not too long ago. So some of the GMap features, some of the buttons will look a little bit weird in dark mode. So you might want to switch to light mode. So what you can do here, right now mine is the light mode. So if you're using a dark mode, I would recommend go to this setting buttons here, upper right corner, and then in the first option here, sim, just change it to light. If you really want to use dark mode, fine, but later your interface will look different, and then some of the buttons, the color might look, the contrast might not be very good. So I recommend for the time being, just switch to the light mode, then you should be good to go. So next, we're going to install some packages. So Gmap is already actually pre-installed. So most of the things we're going to run through that you can actually use that without having to install it again. But because we use some additional dependencies, so I recommend in here on your computer, you can two ways. So we're going to introduce a couple shortcuts how you execute the source code. So you will see this is a green color. That means it's a common. So in Python, basically, it's a common out. That means it doesn't execute anything. So you can remove the hashtag at the beginning using a delete backspace. Then it's going to turn this one into a code block that you can run. So %type pip install is basically installing some packages into this cloud computing environment. Kind of like on your computer, you download some software and install it. And on the left side here, there's a button here. You just click this play button. Then you should install. And upper right corner here, you should be able to see it says connecting. So basically, it's creating the virtual computer and then install the packages into the virtual computer. If you want, you can hover your mouse. You can click this one here. Click on the upper right here, RAM and disk. It's going to show you the configuration of this computer. So click here, and you should be able to see, for example, system RAM 12.7 gigabyte, and the 1.1 being used, and also has disk 107 gigabyte. So it's a pretty decent computer. It may be better than the computer laptop you're using. It's free, so we can use it. Once we close it, it's gone. And also it's GPU. So if you're someone doing deep learning, machine learning, we don't use it here, but you can change the runtime and then change the runtime type. This one also allows to use GPU. So GPU is very powerful for doing computer vision. So if you need it, you can also use it. It's also free. So basically, we don't need to pay anything. We can enjoy the cloud computing power. So after this install, you will see, uninstall. Never mind. So it used to be fine. So they keep changing something. So sometimes things might not work. But after you are done with the installation, then I recommend in here, you can, on the left side here, this arrow, clear the selected output. Because sometimes you might have a lot of output. You can clear it, then it's gone. It's not going to bother you. And next thing I would recommend is to restart the section. So sometimes after you install some packages, if there's some conflict, sometimes basically install software on Windows, and then sometimes you need to reboot. That's it. So go to runtime, restart section, and then just restart it. And then we should be good to go. So next, you can just skip to the import the libraries. So basically for Python programming, Python has basically the core functionality. Gmap basically is built on top of a lot of other Python packages. So whenever you need to use something, then you need to import the libraries. So we're going to just click this one. So there's three ways you can execute the code. I'm going to introduce three shortcuts, and that's all you need to remember. There are not a lot of things you need to remember. So in the Jupyter Notebook, you can either on the left side here, click the button to run it. But there are a lot of buttons you need to click. So usually, if someone that want to do it fast, you use the keyboard shortcut. So there are three keyboard shortcuts you can use: Control Enter, Shift Enter, and Alt Enter. So there's three ways. And most of the time, I use Shift Enter because when you execute this one, you go to the next one, execute this one, go to the next one automatically. Control Enter is going to execute and then stay there. Alt Enter is going to execute and then create a new empty code block. So I'm going to show you three ways in here. So hover your mouse on this code block. Each code block can have multiple lines. So I can run Control Enter. You see the cursor will stay in there. Okay, Control Enter, right? And I can also do Shift Enter. I think on Mac is Command Enter. You see, I should stay there. It's stay there. But I can also have Alt Enter. This one is Option Enter. You see, it goes to the next one. It creates an empty one beneath. So it depends on what you want. If you want to run this one and you want to play with something else, you want to create a new code block, then you use Alt Enter to execute it. Otherwise, you can use Control Enter to run this one, but Shift Enter would be better to go to the next one. So, and then from here, you can write something else. For example, print, right? This is all Python programming. So you can write the function, print something, for example, hello world, right? And then you can run Control Enter again. You will execute it, you will print it out. So it's all writing code. And if you're new to Python, don't worry, you will get used to it very quickly. So this is after you import the library, the next step is to authentication. So this is a step that most people having issues is to authenticate it. So Google Sensing is free for research and education and non-profit, but they want to check the usage. So they don't want you to abuse. You can create 100 accounts trying to abuse it, but you need to authenticate it and also initialize. Initialize means first they need to make sure it's coming from you. You are the one using your account. Next, they need to make sure that you don't abuse it, because it's a supercomputer. You can send a lot of requests. So usually initialization only allows you to have 5 concurrent connections. So you cannot connect too many computers to using your account to their server. So there are 2 steps: authentication and initialization. Authentication is make sure it's you. Initialization, make sure you don't abuse it. So these are 2 steps. So Gmap has this function called initialize, and it's like combine the 2 steps as one, so that you don't have to worry about, oh, do I need to authenticate it or do I need to initialize it? If you need to authenticate, you ask you. So let's try this one out. And so let me run this one, and you will see. You probably will not see this one because I have a key in here, but I will just cancel it. Then you will be using the same settings. So let me cancel, and you should see this one at the bottom here, ask you to authenticate. So all you need to do is to click this link here. Just click the link at the bottom beneath, and it's going to ask you to log into your account. So you should have already logged into your Google account, and make sure here under the cloud project, this is where you're going to select the cloud project. So it's free to create a cloud project. And if it is empty, there might be a star there, ask you to select. So let me zoom in a little bit in here. So choose a cloud project, and if you already have one, you can select from the one here, existing project. I have a couple of those in here. If this is new, you can create a new cloud project. Okay, and just enter a name. You can keep this one as default, and then enter whatever name you like, and then just click select. So hopefully it works. If it doesn't, let me know, raise your hand, because if you cannot pass this step, you will not be able to do anything. You'll be just watching. So I want to make sure that everyone can successfully authenticate. So after that, your project should sort out in here. If you cannot select anything, that means you don't have a cloud project. Then you need to create one. Anyone? Any issues? So choose project. If they already have default one selected in here, perfect. You don't need to do anything. If it doesn't, then you need to create a cloud project before you can move forward. So, and after that, you can click the generate token. If you can generate token, then let me click it. For those of you, so how many of you already have this project selected somehow? A new cloud project? Do you already have one? No? If no, come to here, choose project, and then create a new cloud project. And you can just all set all the default settings. Then click select. So in here, just create a new cloud project. And then you don't need to change anything. Then click select. Unless you see any error messages, if not, then you should be fine. Works fine? Any problems? Okay. Don't worry, we wait for you, okay? We will make sure everyone can go through that. So just create a new one and then select. Okay. Oops, I should not create a new one anyway. Yeah, I do. Did you see here? This is my university account. It doesn't allow me to create. So I created one before they actually enforce the restrictions. So I was able to use my EDU account. So let me cancel. I'm gonna use this one. For those of you who are already create a project, just click this generate token. If you don't have a project here, don't worry, I will help you, but let me continue this step first. Okay, generate token. So the token is basically a one-time password. And here, you're going to see this interface. Just select your account, whatever your Gmail account, select that. Then click here, allow. Your interface, if it is different, if there's any checkboxes, click the checkboxes. Sometimes it's weird, the different account has different interface. And then just click allow. Here you should be presented with this interface. And at the bottom here, there you should see the authorization code. Authorization code. And on the right here, there's a button here for you to copy. Just click the button to copy this one. And then you can come back to the notebook here. And there's an input box. In here, you just Control V. And then hit enter. Then you should be good. Yeah, I will help you. Don't worry. So I just want to make sure that the majority of you can finish this step. And initialization. And then you can move to the next step. So let me run this one. Run the next code block. And also the next one. So if you can see the map, you're all set. If you cannot see the map, raise your hands. I'm going to help you quickly. And then we can move forward to the next section. hopefully you all see the map. Then we can continue. Let me close this one here. So like I said, authentication is challenging if you're beginners, but after that you should be, you know the process. So just authentic again. The only thing in Google Colab sometimes if it doesn't work, if you throw any errors, you can just do this one. So let me show you, like if you're still running into issues, if this one running the E initialize, if it doesn't work, you can do it this way. So let me show you. Go to Colab. You can just type ee.initialize, PIALIGE, and then project, okay, equal to something. So like I said, authentication is through your account, initialization is through your cloud project. So it's two different things. And the cloud project by default, if you already have a Google Sage account, now you should have a cloud project. So you can go to here, go to your account. Let me show you. Just earthengine.google.com and platforms, code editor. So this is the code editor is where you write JavaScript. And you should have a cloud project from there. And upper right corner here, click your account. And basically, the project name is this one that you're using. So you can click that and just click the project info. You should be able to see the cloud project. You can manage it. So the cloud project is tied to all the cloud computing services. Google Sage is just one of those. Okay. And like I said, the cloud project to use Google Sage is free. But if you use other services, you maybe need to pay. So what you can do is just double click here. Just remember the cloud project name, Control C. And so in Google Colab, all you need to do is just say double quotes here and then Control V. Oops, not this one. Control V, no. Maybe I didn't type, but what I can just type it, ebook, something like that. So basically you type the name of your cloud project or you just copy and paste. So initialization is good, initialize through that one. So hopefully most of this, if the previous one doesn't work, this one should work. And then you can run this one again. Make sure you can see the map again. Then you're good to go. So all other, in the future, if you need to run Google Sage, it's the same process, okay? So import E and import Gmap, and then authenticate, initialize, and then we can start doing the cloud computing. All right, so this is the, what time is it right now? It's already 1 hour. Okay, then maybe we'll take a break and then you can come back, maybe have a 10 minutes break, and then we come back to start really using cloud computing, okay? All right, so next one really start having the doing some mapping and also cloud computing. And so you can continue to use the notebook, the Google Colab notebook, it's up to you. But I'm going to switch to my local computer because some of the things may a little bit laggy on the Colab. So if you're beginners, I would recommend just stay there. It's easier. But if you want to use your local computer, so in that way, you don't have to authenticate every time because it's only one time only. I actually have the instruction here. I'm going to show you here at the beginning here. Shows you how to install this one on your local computer. It's going to take another 15-20 minutes. I don't want to waste the time. So unless you really want to, I can show you later. But I already set up everything. So I'm going to just switch to my local computer. But the interface will be very similar. So you don't have to worry about. So you don't have to follow me in the next couple steps. So what I'm going to do here is to go to the Gmap website. And from here, I can download the notebook. So I'm going to go to the top here. You can also download this one to a computer if you want to save a copy. So click the button upper right corner, and then I can save it to my, for example, my local computer. And after that, then I can, open basically notebook for my local computer. You do have to install, so don't follow this step if you don't have that installed. So I'm going to right click, open terminal, and then contact activate Geo, and then Jupyter Lab. So Jupyter Lab is similar to Google Colab, but it's just things running on a local computer. So it's the things, you will see the notebook very similar. So then I can double click here. And after that, you will see the interface very much similar. So here I have the table of contents, and then I can skip through. So I'm going to go to import the libraries, and then just shift enter. And Initialize. Yeah, it's just a little bit notebook. You can do it anywhere. As long as you install the Gmap package, then you should be able to do that. Like I said, if you're interested in setting that up on a computer, I can show you during the break, okay? Because most of you are beginners, so you probably don't want to, I don't want to give you too much. But zoom in here. Let me zoom in a little bit. And then, so I'm going to create a map. So in the same step, and then display the map. So you see, it's much faster when I'm on my local computer. So as long as you can see the map, you're good to go. So this map basically is what Gmap is about. You build on top of a package called IPyLeaflet. So IPyLeaflet is a mapping library, allow you to use the Leaflet JavaScript library. So, and you will see the two buttons here, the one upper left corner here, and also the one on the right. So if you hover your mouse, or you click, if it doesn't show up, you click it, you should be able to see these buttons. So this is what Gmap is about, is to have these widgets allow you to interact with the map. So by default, it's going to create a map at the global scale. And if you want to zoom into a specific area, for example here, you run this one again, this map is centered around the US. So you see here gmap.map and then center. So basically the package map is a class. So basically we're creating the map and center around, this is the latitude, this is the longitude, and this is the zoom level. So by default is around I think 20-degree latitude, 0-degree longitude, and then zoom level 2. So zoom level basically means the larger the number, the more detail you can see. So right now, for example, if I click this button, the zoom level will be what? 3. Okay. If I click again, zoom level will be 2, and then 1. Let's see, zoom 1 all the way to 24 or even 30, depends on the imagery that you have. So basically, if you want to create a map by default showing some location, then you do it like this way. So you go to the set the latitude and the longitude. Okay, so this is by default the US map. I can also create a map, for example, around the area here, Michigan City. So take a look at this one here. Right now we are centered around this location, latitude, longitude. So there are different ways you can get the latitude and longitude and also the zoom level. If you really want, you can go to, for example, maps. Let's say here, maps at google.com, right? So you can go to the map to find out any location and the latitude and longitude. So if I come in here, I can just say maybe right click. And then at the bottom here, you should be able to see this one, the latitude, longitude here. And then you can just copy and paste, right? So select, Control C, and then you can come back to here. You can replace this one with whatever number you get from the map. Or if you already know the location, that's fine. So make sure you backspace. So within the square brackets, and this is so-called a list, latitude, comma, longitude, and then you can run again. You will see the map. So the zoom level, for example, right now is too small. You can zoom in a little bit and zoom in a little bit, right? So here, also you can get the location from here if you want to. So let me show you. If you want, you can lower left corner here. There's a measurement. So I can click this one, and I can hover my mouse somewhere here. Oops. Right now this is a bug, so it's kind of jumping around. But you can also get the latitude and longitude from here. Latitude and longitude, but here using the slash. So if you copy this one, you might need to change the slash to comma. So I'm gonna come back to here, for example, Control V, and then you need to backspace, change the slash to comma, and then you can run it. Okay. Whatever way you want to get the latitude, longitude. So I guess if you're doing GIS, you know how to get the latitude, longitude from somewhere. And the zoom level, you can get the zoom level. So the nice thing about this is that the map is so-called bidirectional. Bidirectional means that you can create a map, you can interact with the map, you can get the result from the map, so to get things out. So here we are displaying the map, the variable. So the map is a variable that has a lot of attributes. So for example, I can create a new code block here beneath, okay? And then you can just type M. So we are accessing the map that we created. So if you need to set something, you need to change something, you can do it from here. For example, map dot. And then if you're using Google Colab, you should see the list automatically pop up. So for me, I need to hit tab. Sometimes it's a bit slow, but you should. You see here. So when you're hitting the tab, you should see this the list of all the attributes associated with this one. So this is so-called object-oriented object-oriented language. That means it's an object. It has something attributes. It has properties. You can have two events. Just think about each individual people, right? You have your attribute. You have your color. Your height. Your weight. You can walk. You can punch. You can do anything you like. So object can do all kinds of things. So here, for example, you can just type M zoom, for example. If you see an eye, that basically is an attribute. Okay, zoom, and then you here, and then you can just like control enter. See that? It's going to show you the zoom thing, right? You can change it if you want to. So look at the map above, right? Right now it's sending, it looks like this. So map zoom, you can space at the end equal to, for example, I can zoom equal to 20. So you can change the map. Even after you display the map, you can change it if you want to. So change it to 20. I can control enter again. Pay attention to the map above, okay? 1, 2, 3. 20 is probably too much. The zoom level is too high. But I can set to maybe 15. Run again. You see? So again, this is so-called bidirectional. So you can generate the map. You can get something. You can pass it back to the map. So you can change. You can change anything you like if you want to. You can also set the center. For example, I can do here. Map.center. You can run it to see what it is, right? I can change it. For example, I can say center equal to, right, square brackets, and then latitude, comma, longitude. So here I can say 40-degree latitude, comma, negative 100, basically the longitude, and I can run it. You see, it's going to center somewhere else. So everything is very flexible. You can change a lot of things. Also here, for example, you say, okay, you can do layers, m.layers, and then run it. It's going to show you all the layers available in there. So right now we only have a base map layers. There's nothing going on here. You can clear the layers if you don't need the layers. So for example, here I can say m.clear, and I hit tab, clear layers. Then you see the layers gone, right? And you end up with a blank one. You also have a lot of controls. I can clear the controls if you don't need the controls. Sometimes you see the map is too crowded. I don't need those widgets. You can do it as well. So here, m.clear, hit tab, clear controls. So these are all the functions. So you need to have the parenthesis at the end, basically calling the function. So if I run this one, you see it's gone. So think about the map is Lego. Lego, you can build things, you can take it out, you can add things. It's just like a widget. So everything on the map is just a widget. You can add layer, you can remove layer, you can add all kind of things. So we're going to show you a lot of examples later on, but for now, nothing here, not useful. So certainly you want to have something. And also you can by default, you can run this one. So this one, by default, you're going to see a lot of widgets, but we can turn those widgets off. So the data control is the upper left corner, the button. And the toolbar control is the one in the upper right. And also the drawer control is the toolbar on the left side. All right, so let me show you the differences. Again, if you don't, here I can just gmap.map. All right, show you the differences. Right, by default, this is what you have. So if you don't need this button, you can turn it off. If you don't need the button on the right, you can turn it off. If you don't need all of this, you can turn it off. So like I said, everything can be removed, can be added. It's up to you what you want, so you can customize the map to whatever you like. So this is creating the map, and so you will see the M here. The M basically is just the variable name. So if you have the same name, it's going to override the previous one. So the variable name needs to be unique. If you use the same one, the previous one will not be accessible anymore because it has been overwritten. But you can choose M1, M2, M3, whatever. You can choose whatever name for your variable. It doesn't matter. But just for to follow the convention, we just use the lowercase map to see it, to use it. So next, how about this? You can change the base map. So earlier I was using the OpenStreetMap, right? By default, using the OpenStreetMap. But you can change it to satellite map. You can use to all kind of maps. So here we're using the set the parameter base map equal to Esri world imagery, right? So just like you're using ArcGIS, you can change the base map, and then you can zoom in, you can zoom out, right? So here, this is the Esri base map. So after you display the map, you can call the function called add base map. So you can add another one if you want to. So I can run this one. You see, I can add the H3 topo map. I can add the open topo map. You have a local data layer you can have access to. So here we have 3 data layers. So one thing I will show you here, this is where the Gmap that can help you easily visualize the data. Upper right corner here, there's a button. So click the button, and then here there's a hamburger icon here. So if you click this one, it's going to show you the data layer. So this is where you can turn layer on and off. So make sure your mouse is here. If you hover out, it will disappear. Okay. I think in Google Colab it might stay there. I forgot what it is, but if it doesn't show up, you can click again. Click this one. So now I can turn this layer off. Turn this layer off. Turn this one. You see all the data layer are interactive. You can change the opacity. So there's a slider here. So you can click and drag your mouse. You might need to drag your mouse. All right. So everything is changeable. You can easily change it. And also here, like this. You may not see these buttons. I think this is a new feature I have not released yet. So probably you don't see the cross button. This is allow you to remove the data layer. So I can remove it. It's fine if you don't see it. It will be available in the next release. So this allows you to change layer interactively. And you might be wondering, how do I know the name of the base map, right? How do you get the name of the base map? So here, if you run this one, it's going to show you all the base map available. So it has 145 base map. You can show you the first 10 or something like that. So the easiest way would be like this. Let me come back here, go to this one. And so if you don't select anything, for example, by default, let me remove everyone, right? So the easiest way to create a map would be gmap.map, and then just display the map. And after that, if you want to change the base map, you come here, upper right corner, and then the second row, the first icon, second row, first column, click this one, change base map. And then here you can select all the base map available. So 145. So you don't, just like in ArcGIS, you can change the base map. So for example, now I can change it to the H3, for example, National Geographic map. Right? I can change it to how about the NLCD, for example, National Land Cover Database. It's going to add the local data layer to the map. So it's up to you what base map you want. So the name showing up on this drop-down list is the name that you need for your map. So after you, for example, okay, I create a map, I don't want to use the land cover map. You either type the name manually, or you can come here. Let me show you. Once you add the map, I can just create a new code block and then m.layers. Right? So from here, you should be able to find the name. So if the name is too long, you can just copy and paste. So in this case, I'm going to look at this one here. It says the name equal to NLCD HONAS land cover, right? So it's this one. And then you just say Control C, okay? And then you can come back to the map in here. And I will just say m.add base map, okay? Hit tab. If it doesn't show up, that's fine. And then just double quotes, Control V, like that. So next time if I run this one, you see I should have the base map in here. All right, so how depends on how you want to do that. And also I can center the map, for example, center equal to, so I know the US is 40 degree latitude, negative 100. And then the zoom level will be equal to 4. Run it. So this is how you can customize the map, any base map you like, and use that as a default setting for all your project. Questions? Yes? No, in Google Colab, it should be saved automatically. If it's locally, you need to save manually. So you're going to see the button here. I'm not sure if you can see it. My mouse here, there's a dot. That means it's not saved. I can Control S. And you will save it to your computer. So in Google Drive, Google Colab, it should be automatic. You will save it automatically. If it doesn't, you can always Control S to save it explicitly. So that's about the base map. And there are, as I mentioned, there are 145 base map available. So you can choose whatever you like. H3 one, Kato one, for example. Some of the, maybe the Kato Dark Matter, for example, right? So there are a lot of cool base maps are available. And you might notice on the listing here, Google-based maps are not very available due to some licensing issues. In the early days when I initially developed, I have that here, but after Google officially take over, then I have to deal with all the licensing issues. They don't allow it anymore. But it's at your own risk. If you want, you can still use it. And we're going to have a new version coming up that will make it easy for you to load the layer. But for now, here's all the URL. So if you really want it, you can use this way. So run this one. This one is the Google base map. It's like Google Earth space map. So this is the hybrid. You can see here. You can zoom in. You can see the layer name, the label name, and this is the URL. So think about this is like web services, the tile services, and then you can use the add tile layer to add it. So all you need is just the URL, and you can change it. For example, if you want just the satellite without the label, then you can just select here, copy this one, Control C, and then you can replace this one. Okay, so you can come to here, replace, Control V, run again. You have the new base map. So like I said, everything is just a layer. You're going to add a lot of layer to the map. You can change layer. You can also add your own. So if you're working in Indiana government, I guess you have all kind of web services, high services. So if you have the URL, you can replace the URL. It should be the same thing. So you can also load, basically you can load data from everywhere. As long as you use the public protocol, it should work as well. So that's about some simple map customization, how to change the location, change the zoom level, add some base map, that's it. So right now, this is nothing Google Engine yet. It's just web mapping. And next, we're going to get into Google Engine, how to really utilize cloud computing. And as I mentioned, Gmap has been adopted by Google. So if you go to the Earth Engine documentation, for example, if you click this imagery, it should take you to the Google Engine documentation. So this is where all the JavaScript, oops, let me zoom in a little bit. So if you go to the Earth Engine documentation, they have a lot of examples. So if you really want to dive into Google Engine, I would recommend just go through the documentation just to figure out what Google Engine can do. And if you need something, you can always go back to check it. So for all the documentation, you want to see, for example, here, visualization, you want to have two tabs. The first one is called Code Editor, is the JavaScript version. The second one is the Colab, is the Python version. And if you click the Python setup, you will see here gmap.core. So basically, Google Engine support the core functionality. But if you want to use it, you just import Gmap. You don't need to import Gmap.core as Gmap. It's basically just a small subset. Makes it easier for them to maintain, but you can just use the full functionality. Just import Gmap, everything else remain the same. So all the example here, you can just come here, for example. I can just copy this one, for example. Copy. So any example you get from documentation, you can just copy it, and then you can paste, and then you will be able to run it. So here, I'm going to show you some of the core functionalities. I have a video here. If you want to watch the video, if you click that, it should take you to show you all the core functionality. So I already showed you the one earlier. You can change the base map. You can change the visualization. So this is just a quick demo. But we're going to use the step by step, show you how to do that. And the base map, you can, for example, turn layer on and off. So raster data, vector data, you can change the opacity. You can do the inspector. You can do the clipping. So there are all kind of functionalities, just like traditionally how you do that in desktop.js. For example, you can change the visualization, different color, something like that. Again, the data might be many gigabytes. It's not on your computer. So always remember, it's computing on the fly. So whatever you do with the map, you get something or you want to set something, is sending to the server and then return the result back to your computer. And nothing is saved on a computer. So everything is on demand. And it's really fast. You can change settings for gigabyte data, petabyte data, doesn't matter. And always remember, like I said, large area, coarse resolution, small area, high resolution, but the file size is pretty small and tiny. And it's thousands of computers handling the task. And this is why it's really fast. So you can, for example, check the property, see what's in there. Just like in ArcGIS, right? You click a polygon, you're going to show you the attribute. But keep in mind, the data is not a computer. So you need to get the coordinates. So Gmap get the coordinates, send the coordinates to the server, ask it to check the result, and then send it back to your computer. So those are some of the features, but we're going to go through that here, and so that you can play with it and see how to use it. So let me scroll down to here, and then a couple of things is that if you're new to Python programming, different platforms sometimes might function differently. I'm using this is called Jupyter Lab or Jupyter Notebook. It's a little bit different from Google Colab, some of the keyboard shortcuts or something like that. So one thing you really want to do in here is, let me show you. I have this one. If I type Gmap, for example, dot, and then hit tab, you're going to show you the list. If you, in Google Colab, it should be Gmap dot, and then it will automatically show you the list of all the functions. And then I can say, for example, map. If you type one case and then hit tab, it should auto complete. Then I put the parentheses in here. Inside it, I can press the tab or shift tab or something like that. And you can see all the documentation here. Hit tab to display it. Yeah, this one doesn't. Yeah, it doesn't work in here. Anyway, yeah. But usually, I mean, most of the time you will just, for example, m.doc something and then just hit tab to see the list. So in that way, you don't have to worry about memorizing all the stuff. And so next, let's get into the functionality, how we actually access the data. So Google Sensing has, let me show you here. We talk about data first. Let's go to some of the core functionalities that Google Sensing officially support. And this one. The first one is called base map selector. So this is the one I already showed you earlier. And the only difference here is map.add something, the base map selector. So you want to show this one by default. If I don't do that, so for example, yeah, I can Control/ to comment this one out. By default, the map will look like this. But you can always click and then select this one. It's the same thing, okay? Base map selector. So if you Control/ run this one. And the idea is that sometimes you have developed some custom widget. When the user create a map, you want to sort it by default, then you can use the map.add something to do that. And so in here, now I can select different options, right? I can do it in here. So this is so-called the base map selector. Second one is layer manager. Similarly, run this one. And now we are really accessing Google Sensing. So now you are watching a movie, okay? Different movie, action movies, romantic movie, whatever. So we are accessing, for example, the DM, USGS DM, and also the Tiger dataset, basically the state boundaries. And also, this is how you visualize. It looks quite complicated, but I will show you other ways to do that easily. For now, just assume that, okay, I want to see some DM. You see here, this DM is global scale. It's pretty big data set. And so the layer manager allows you to turn the layer on and off, right? So I can turn this one on and off. And I can change the opacity by dragging the slider. Similarly, you can do this one as well. And so here, this is what all the data set about. So Google Sensing is so-called the server-side object. All the data in the cloud is not on a computer, so it goes server-side. And there are three different types: image, feature collection, and image collection. So those are the three key types. Basically, image you can think about is a single image, just like you have an image on your computer. Feature collection is just like vector data. You can think about it's just like a shape file on your computer. Feature collection means you have a bunch of features. So feature collection composed of feature and then geometry. So geometry is just the shape, for example, polygon. And then if you have some attribute associated with it, it becomes a feature. Okay, so for example, a state polygon for Indiana, and then you have a bunch of polygons, then become a feature collection. So it's similar concept, just like shapefile, but this is what they call the same, different terminology, but it's the same thing. So one image, bunch of images become image collection. A bunch of polygons, which actually becomes a feature collection. We're going to, basically, these are the three types. So everything here, I want to show you this basically EE-doc something. All the Google Sensing object will be EE-doc something. So you can think about it's a server side. It's a black box actually. So the data, EE-doc something, basically are pointing to the data. EE-doc image, you're asking Google Sensing to point to the DM, and then you can do things with the DM, but you don't actually have the DM on a local computer. You can say, for example, Netflix, I want to watch the Titanic. Point to the Titanic, and then you can say, I'm going to watch in certain seconds. I want to watch the specific thing. Then you will extract the data out and then show you. Same thing in here. You don't actually have access to the data locally. And this is how you visualize it. visualization parameters. So this is similar to ArcGIS. You open the imagery, you open the settings, symbology, and then change the color palette. You change the minimum, maximum, to the stretching, something like that. In Google Engine, you need to figure out how to do that, and it's different, but you have precise control about how you want to do it. So here is a DM. You set the minimum 0, maximum 4000, and also the color palette. Color palette basically is the 6-digit hex color code. The first two are the red, and then 3 and 4 is green and blue. And hex color code basically from 0 all the way to F. 0, 1, 2, 3, 4, 5, 10, and then A, B, C, D, E, F. So 16 digits. So RGB. It might be difficult to remember. So if you're someone that don't know this, you don't have to memorize it. I can remove it, and I can just double quote. I can just say terrain, close the double quote. So, and then run it. You see different results. Now I have the terrain. So it's very customizable. If you know Python, this is from the matplotlib color palette. I can change it to cool warm. You can play with it. If the name doesn't exist, it will throw the errors. But this you see here, we are basically requesting the data on the fly. It's rendering the data. And again, so if I zoom in and zoom out, let me show you here. You might notice on the right here, you don't have this one yet, by basically loading the data. So if I zoom in and zoom out, you will see it's like loading the spinner, loading the data layer. So it's requesting the tiles from the Google Engine server. And zoom out, you will see that. And you probably don't have that, but I can show you behind the scene how this actually functions. So I'm going to more tools, and then maybe the developer tools. You might not see this one. So this is where actually the request is sending on the fly. So if I zoom in, zoom out, you see those photos. It's coming up. So behind the scene, it's downloading a bunch of smaller tiles. So for example, if I double click this one, see if I can see it. You see right now it's like it's grayscale. It's probably just this one here. So if I zoom out a little bit, you may see here, really slow. You see here, see those images, and so if I click it, look at this. So just like you're using Google Map, under the hood is downloading a small tiles, and this one is after it's rendering, so it's not the original data. So for example, your computer might be have a GeoTIFF. It's the same thing in the cloud. It's kind of like GeoTIFF, but when it transports the computer, it's basically a bunch of PNG, smaller tiles, and then put it all together. So this is why it looks like this is the complete map. But under the hood is one small tile, one small tile, one small tile. So it's requesting the data on the fly, and it's very, very fast if you have internet. And this is not going to be an issue. So anytime you zoom in, zoom out, you're going to send a request, something like that. So you can always check what's behind and to see how. And you see all the data layers being combined as one single data layer. So just single map. So this is how you change the data layer, zoom in, zoom out, and for example, if I don't need the layer, I can remove it. Again, you don't have this one yet. You'll be released probably later this month. And so this is so-called the layer manager. The next one is the inspector. So run this one. Let's play with the inspector. So the inspector is allow you to inspect pixel values, vector data, raster data, whatever data you want. So here, right now, we have 3 data layers. The first one is the DM, and the second one is the Landsat data, global scale, 5-year composite, and the last one is the vector data. And for any of these things in here, you might be wondering, how do I know the name? You can think about each imagery. Everything in the data catalog has a unique ID, kind of like a social security number of people in the US. So if you want to access it, you need to point to it. If you want to see some metadata, you can just, for all the example I'm showing here, you can select the name, Control C, and just go to Google, Control V. You should be able to find it where the data are coming from. So for example, this is from Google Engine. You can click it, and we see the data in here. So this is where it's coming from. And you can see the property, you can see the resolution, you can see what spectral bands it has, you can see the examples. So there are lots of things. So basically, it might look complicated right now, but everything is coming from somewhere. You can Google it to find it out. So I'm going to come back to here. And so we have 3 data sets, actually 4 data sets, right? And all global scale. So again, what you're seeing here is a couple gigabytes, but it's very fast. I don't download anything. And zoom in, can zoom out. So the inspector tool is allows you to click the pixel value. So for example, I can hover my mouse somewhere, just click that. You should be able to see, for example, here we have the DM, the elevation, we have the landscape imagery, multi-spectral bands, and we also have the vector data, right? So a feature, so you can click the plus icon to see all of that. Because they are local information, so you might need to click to see the attributes. Otherwise, it's taking too much space. And so I can click somewhere else. You always, so again, what we're doing here, if you click your mouse on the map is getting your coordinates. And then it's going to send the coordinate to Google Sending Server. And then run the analysis, intersect, get the pixel values, and then send it back. So this is why you might see sometimes if your internet is disconnected, you will not see the result. It's different from Esri, for example, a desktop GIS. You click, you get a pixel value, all the data on local computer. This one is not. You need the back and forth computation. But it's still pretty fast. You're getting the pixel value, you can do it for any location. So if you just, for example, here, if I'm only interested in the vector data, then I can do it here. I can turn the layer off. For example, I can turn the other two layer off. Right now, I'm just having the vector data. So here, I can uncheck this box, pixel, and then click the object. That means I want to see automatically expand the object. So now I can, for example, click here somewhere, for example, right? And Indiana, so you see it's automatically. So you see, basically this is a swap file. Let's think about it's a swap file. You click it, it's going to show you the attribute table. So this is what the attribute table, information from the attribute table. So you can click anywhere, it will show you the attribute. If you're looking at just the raster data, then you want to check this one, uncheck this one, and then check this one. And then we can turn the, for example, if you just want to see the landscape data, I can click. It will just show you the pixel values, right? So for example, if I was interested in water, you will see the pixel values for all the water pixels. Okay, so this is about the inspector. So next, let's look at the other one, layer editor. So this one is where GMap makes it so much easier to visualize. So if you remember earlier, we need to set the minimum, set the maximum, and then set the color palette. But you can actually have the interface to do that easily. So we are loading some data, and lastly, we add this so-called layer editor just to show you. And this is where you can change the color map. So low right corner there, you can scroll down. There are lots of color maps available. And I can just, for example, select, how about this one, terrain. And you will see the preview of the color palette. And then you can just say apply. Then I can change it. Also, you can change the range, right? So from 0 to 4,000. So imagine here, if I'm switching this one to be a smaller one, for example, 2,000, something like that. Or you can double click on the right. You can enter a number if you want to. So you can double click and then enter 2,000. You enter. So if you want a precise number, you can enter it. And then just, so if I click apply, what's going to happen? So you're going to see more this kind of a white color or less. So pay attention, right? Apply. You're going to see more because anything above 2,000 is going to be color with the white color, right? Or if I change it to a larger number, you're going to see less white color. So depending on how you want to do it. So you can do things very quickly, right? Less than 1 second. It's sending the request, get the data back. Less than 1 second. You don't need to download the data. You can do it in whatever way you like. And then we can close it. So you might be wondering, like, how do I know like how to actually do all this? You have the data, then you need to do visualization. You need to figure out how I'm going to visualize that. So let me delete all this, and then I can show you the easy way how to do all the stuff. And so by default, this should be easier to understand. So I create a map. I pointing to the DM, and then I use the map.add layer to add the DM. So the first parameter is the object DM. The second parameter is the visualization parameters. So you will see I have the curly brackets empty. That means I don't know what to input in there. I just want, just like you open ArcGIS, you drag the data layer and then display, then you can customize it. This is similar. So you don't know what to put in there yet. And the third parameter is the layer name, what's going to be showing up on the table contents. So this one to see what happened. Right? By default, you want to look like this. Nothing fancy, it's just a grayscale imagery. But so that it doesn't look good, right? So this is where you want to change the customization. So the easiest way would be, if you're interested in seeing any data, just pointing to the data and then just use the map.add layer. And then you can just pass in an empty one. That means you don't know what to put in yet. And after that, this is where you can change it. So go to this hamburger icon again. And there's a settings button in here. So this one is the one I showed you earlier. So if you click that, it should pop up something like this to show you this is the default parameters. So just like what we did earlier, because it's DM, I know like from 0 to 8,000, 6,000, whatever. So I can type 4,000, hit enter, and then color map. Choose whatever color map you like. So I'm going to change the one to terrain as well. Apply. See? Easy it is. So this is where you can have this interface to help you figure out the parameters. So for example, if 2,000 is too much, I can change it to maybe 6,000. Hit enter. Apply again. Looks better now. And there's a button here called import. The import basically you can get, after you are okay with the settings, you can get the visualization parameters to pass back to your program so that you don't have to remember or ask people like click this one, click that one. So import, it doesn't do anything because it's copied the source code to the clipboard. Then I can come back to my source code here after the DM and then say enter, Control V. This is just probably too long, but we can change it later because it's getting all the color palettes 255. It's probably just too much. So I can move it down here. This is probably a bug. I should have made it easier. So now with this, I can copy and then replace the curly brackets with the parameters. And now if I run it again, oops. Interesting. Color can both a function error. Gamma, okay. This is a bug, so I permit to fix it. But anyway, easy way would be just to remove this one, and then the color palette, for example, would be gray, and then minimum. So once you figure out all the parameters, you can type it, or you can just be minimum 0, and then max. For example, 4,000, and then curly brackets, and run it. Okay. Let me see, what did I color? Oh, I removed the data layer. So, and then map.add layer, and then just put in the layer name, the object, and then the visualization parameters, and then the layer name. So DM. Then you should have it. So basically, you can get the parameter from your customization, and then going back to change your source code. But for all the examples, you can just run it. You can make some modification. It's up to you. But what I'm saying is, Gmap has those interface allows you to change easily. So for example, even after you load the map, I can change it and come back to here again. And then I click this settings icon. Right, so here it's going to show you all these parameters. And same thing, I can change it maybe to blue. Apply. Change to blue. So very easily you can customize it. So this is for a single band, but you can also do multi-spectral band, right? So I'm going to load a lane set imagery. And by default, I let at the layer editor. So here you can change the band combination, right? So this is first color composite. I can change it to another first color composite 543, for example. Hit apply. See something like this. So this is very much similar to the desktop GIS. Again, you don't download the data, you are streaming the data on demand, on the fly, and it's really fast. So this imagery itself is several gigabytes. You can access any data. So basically, you can stream any data you like. And similarly, right, I can click the import button, and you're going to copy the parameters to your clipboard. And then I can just come here, paste again. You see the visualization parameters in here. And this is essentially this one, the second parameters. This is the one that's controlling the parameter. So I can say VIH parameters and then run again. You see, now I'm loading using the one. So you can play with the interface and then get the parameters and then save it. And then now your code, so whatever you use, you will be fixed. So user don't have to customize it. You can decide what you want to provide to them. So this is about the multi-band visualization. Next one, feature collection. So feature collection basically is vector data. And by default, we are showing this one here. We are pointing to the feature collection, basically the vector data. And then we are doing the same thing. So all the Google engine is using the same like mechanism to add the data layer. So it's m.add layer, and then the parentheses. The first one is your object, basically your data. The second one is how you want to visualize it. The third one is the layer name. So again, I can hover my mouse here, Shift tab, you'll be able to see the documentation. So you can basically, the map can add vector data, can add raster data, can add a lot of stuff. And again here, empty brackets. I don't know what to put in here. I know I want to visualize the vector data. So you can just point to the data and then edit. Then you can use the interface to customize it. So here I can change it. For example, I want the color to be, so the first one is the light color, the outline. For example, I can change it to maybe somewhere the blue color. And then for the fill color, I want it to be, maybe I don't want the fill color. You can change the opacity to 0 and then just apply. Okay, so now I have the blue outline without the fill color. So everything you can easily customize it. So if you want some color, you can change the opacity, for example, 50%. And then the color, for example, I want the maybe the pink color. And then, oops, and then apply. You'll be able to see that. So everything you're seeing here, this is the vector data from Google Sensing. But when it renders on the map, it's PNG. So you're not accessing the original vector data. You are pointing to the data, so when it comes back, when you transport to your browser, it becomes PNG. So you cannot just simply click on the map and then trying to inspect the property. It's a little bit different. So anyway, once you finish this one, again, you can click the import button and then you can customize it. Like click the import, and then I'm going to come back to here, paste it, something like this, the style. And this one is a little bit different. So the style, you need to have a function here, the object, and then dot style. So vector data visualization is different from raster. You provide the parameter in the second one. But for raster, for vector actually is in the object. So the style is basically telling Google Sensing to style this vector, and then it turns it into a raster, and then you are visualizing the raster. So we're going to put the style and then parentheses, and here will be star style. Basically, it's a dictionary. For even beginners, you probably have no idea. Just trust me, it will work like this. So now if I execute it, it's the same thing that I earlier using the interface. So everything is, you play with it, you figure out what parameters it's going to look like, and then you go back to the source code, and then you change the source code, and then you will be exactly, the map will look exactly what you want it to look. So there's about some simple visualization, vector data, raster data, image. And the next one, I'm going to quickly show you here the draw control. So the draw control allows you to get information. For example, here, this is the global DM. And assume, for example, I'm going to come here. I'm working on the mountains. So right, you can use the draw rectangle. I can come here. I can draw a rectangle somewhere. Okay. So this, you can draw any polygons you like, and then you just run the next code block. So take a look at this one. See, I'm clipping the DM. Right. So if you are using desktop GIS, you have a large DM and you clip. It's gonna take you a couple minutes to save the data, especially with high resolution. This is seconds. It doesn't matter how high resolution it is. It's seconds. And like I said, it's cloud computing. It's right now the area is pretty small, so it doesn't look pretty big. So if you can zoom in, you can also remove the, on the lower left corner here, you can remove the polygon. So now I have this subset of the DM that I'm using. You can produce, we'll show you more features later, but this is just some of the core functionalities. So the draw control allow you to draw polygons. And so this code block here at the bottom basically means that if you don't draw a polygon, I'm going to use the default one. If you draw one, I'm going to use your polygon. And so here, let me, one more time here, let me click, and you can draw a rectangle somewhere, and you can get this polygon if you want to. So I can create a new code block and just type m.user ROI, m.something. User ROI is going to show you this polygon, all the coordinates. So this is the Google Essential object. So what I'm saying is this is the bi-directional. So anything you interact with the map, you can get the information out. So if you draw a rectangle, you add a point or something, you can get the coordinates. So m.user ROI is just getting the last one that you draw. I can also m.ROI coordinates. So sometimes if you just want the coordinates, you can do this, right? So basically the bounding box, this is about the coordinates of the bounding box. So lower left corner, upper right corner. So longitude x, mean y, max x, max y. So sometimes you might be creating a map, you are playing with that. You draw a rectangle for your study area, and then later you want to use the rectangle to filter the image collection, filter landscape data, then you might need to get the coordinates. This is an easy way for you to do that. And you can also create multiple polygons. For example, I can create another one, something like that. In here, I have two. Then it's going to be map.user ROIS. So this shows you have feature collection, you have two polygons, you have two features. We use some of those later, but for now, just showing you if you want to use the create some data polygon, you want to clip the data, you can do it pretty easily. Okay, any questions? So those are just show you some simple visualization functionality. And then next, what time is it now? It's another hour now. Really runs very quickly. Maybe let's have another 5 minutes break, and then when we come back, we're really going to look into how do you search data, how do you search movie, and how do you look at whatever title movie that you want, and then we start doing a computation. Okay, so maybe have a 5 minutes break, or maybe you want 5 minutes or 10 minutes. 5? Okay, 5. Then we come back at 11:06. Okay. All right, let's continue. So in the next section, we're going to talk about how to source the data, okay? And so Google Essential has over 100 petabyte data. It's a huge data catalog. You need to find out like what data you want to use. Just like there are 300 million people in the US, everyone can do something. So you need to find a social security number. If you find it, you can ask them to do things for you. So there are two ways you can source data. The first way is to just go to the website. So if you go to the earthengine.google.com, in the menu here, you will see the data set. If you click the data set, you're going to open another tab, and it's going to show you the tons of data set. It's going to show you by category. For example, we order data set, Landsec, MODIS, Sentinel, so those are the popular ones. Or you can browse we order data set, or you can see the category. Climate, weather, surface temperature, Landsec. There are tons of data available in here. Or for example, high resolution, or I can click showing here, Landsec, right? So it has all the data pretty much back to the 1970s. So right now, the collection 2, Landsec 9, 8, 7, 4, or even the MSS from 1972. So all the data from USGS is being already ingested into the cloud. Also, the nice thing about Google Essential Data Catalog is they have the pipeline to automatically get the latest data from USGS. So these satellite Landsec 8 and 9 are still running missions. They're getting new data every day. So data are getting into the USGS ground station, process data. Once it becomes available, Google will take the data and then ingest into it. So you're going to get the latest data. For example, I can click Landsat 9, and it has different data products, surface reflectance, top of atmosphere, and also the raw imagery. So you might want to use the surface reflectance. And you can see here, data availability, right? From 2021 to right now, May 10. It might have a couple of days lag because USGS need to process the data, and then Google need to tag it. So name a couple of days, but usually it should be less than a week, something like that. And so you will see here, this is so-called image collection. So that means in the entire data catalog. So I don't know how many millions of images in there, but you can think about, you have entire, you're pointing to the image collection. So you're pointing to all the images, then you can run computation. So we see me like in here, I want to do something. I know people, for example, in Indiana can do something. I say, pointing to all the people in Indiana, each of you give me $10. And then I become very rich. Right, same thing here. I have million images in here. I ask you, each of you extract the surface water, each of you by yourself, and then give me the surface water dynamics. You can do it very quickly. So that's why you don't need to download data. You just pointing to them, ask them to do something. So I want to show you how to access data. But within the image collection, you're going to have a lot of images. So image collection, you can think about, is a directory on your computer. Within the folder, you have each images. So this is the unique ID to that folder. And each image is also going to have a unique ID. So basically the social security number of that. So I'm going to show you how to get numbers later. For now, this is how you access all the data. And again, if you want to find any data, you can just view all the data set, and then you can just search it. So here, there's a filter the data set, right? So imagine you're working on maybe there's a elevation, right? You're working using DM. You can type elevation. You're going to quickly filter all the elevation data. So look at here. There are tons of elevation data set ranging from HRDM 90 meter to even, if you look down, there should be, for example, the 3D, for example, 1 meter resolution. Look at this one. USGS 3D 1 meter resolution. We click that. So if you're working in the state government GS, you probably already have access to that, the DM. And this one is, I think, couple 100 terabyte. And just this 3D 1 meter. It's very high resolution. And you see, you have access to that. You can visualize data easily. So here, if you're using a JavaScript code editor, there's a button here, open in code editor. So you can just open it. It will take you to the code editor, and then you can see the data. So basically, this is how you search the movie. You click the play button, you watch the movie. But this is using JavaScript. So here, once it opens up, it's using the JavaScript. There's a button at the top here. Say run. You need to run it. And look at that. So we are loading the 1 meter DM. This is huge data set. So when you zoom out, it's going to take some time. Like I said, the resolution right now is, the original data is 1 meter resolution. What you are seeing here is not 1 meter resolution. It's probably a couple kilometers. But you still need to aggregate all the data. Think about here. There are a lot of image tiles. You need to aggregate and then render a coarse resolution. But what better way can you visualize data without having downloaded it? If you're looking at, for example, I need the data for Indiana. Good luck, go to the GS portal to download data, maybe one small piece, but you cannot really visualize all the data all at once easily. And this is at a national scale. Depends on what data you have. It may be national, it may be global. And also can do computation. Like you visualize data, you're actually having access to the original data. So in here, I can go to the inspector, click the inspector tab, and I can click your mouse in here. It will show the elevation. So basically, not just visualization, you have access to data for computation. You can run a lot of computation. We'll show you more later. For example, click somewhere, you see, you're getting the elevation easily. And this, I don't think this one has the date. Yes, I will show you. This is just right now, just showing one. We'll show you how to filter the data, how to find the data. For example, okay, I want all the Landsat imagery for Indiana or quite last year. Cloud free less than 10%. Yeah, one line of code, you get it. And you can filter all the data, and then you can run computation. So here, this is just one example. Just using the code editor. next, let me show you how you can do that in Python, right? So you can do the same thing. So here, let me create a map. And this is a very boring base map, but there are some widgets in there can help you source the data. So simulate it, right? I can click the button, and then you can search location, but we're going to source data. So this is where you search Netflix movie. I'm going to search Google Search Engine data. So here I can just type maybe elevation, and then hit enter. See that? And very much similar to what we did earlier, search using the website, but now we are searching it using the Gmap. And you can scroll down, you can find any data you like. There are tons of DM in here. Look at this. There are lots of, these are all pretty much global scale, national scale, continental scale DM. So you can select anyone. For example, I can look at select the A-star DM, digital elevation model, and look at it. So you have the date, you have this one. So this one is the most important one you need to get, is the ID. So whether it's an image or it's an image collection, so this is basically the social security number to the image. And you can have the link here, you can see the thumbnail. So next, what you want to do is just click the import button. Once you click that, it's going to show you the examples, okay? And from there, you can just, it's already copied to the clipboard, so you don't actually have to do anything. And then you can come back to here, under the map, and then just Control V. You will see the source code has been copied to the clipboard. And the only thing you might need to change is right now, so in the past we used the map uppercase, now we're using lowercase. So you can either change the map here, the variable name, to uppercase. So in that way you don't have to, you can need to change the source code, you'll be like this. So we create the map and then we load the data. So if you want, you can do this and then just run it. Okay. So we are we are searching the data and then we just run the code, we get the data. And this one is basically using the DM and we're creating a slope. We're calculating the slope of the data set and then we render it. And everything is running on the fly. Again, I'm a bit too quick. Let me show you one more time. So you create the map, you search the data, you copy the source code, and then you come back, you paste, and just look at the last one. So in the future, it will be lowercase m. Right now, we are in the transition from uppercase to lowercase. So you either change this one to lowercase, or you can change the map to uppercase. So you'll use only one. So I can change it to map lowercase, and then run it. Okay, so same thing. So you can basically load any data set you like, copy the example, and then just paste it, run it. You don't have to download the data. It's just a couple clicks, then you can have access to the data. And you can also use the dataset module. So this one, let me run this one here, just show you. So Gmap has the dataset module. So you can either search the data, or if you already know like where the data, what's the provider, you can run this one and then create a new code block. I can show you here, data doc, and then hit tab, data doc tab. So this one basically show you all the categories. So this is more like the hierarchical structure of the entire data catalog. Imagine this would be like Netflix movie, and then they're going to have different categories: action movie, romantic movie, sci-fi, whatever. So this would be like, okay, the database doc, and then I can find, for example, I know the data come from USGS or something, right? Data doc, you can just type USGS, and then it will show you all the data set available. So, and then you can type, for example, I want the 10-meter DM, you can select that. So in that way, this is for those people that don't want to use the mouse. I just want to type the keyboard, just like hackers, and then very, very quick, then, yeah, you can do it like this way, and then just run it, it will show you the ID, okay? So turning, this is called doc notation, so you can have access to the entire data catalog like this way. But usually, if you already know the ID, then you don't have to use it. I'm just showing you that there are multiple ways you can get the data. So, for example, I want to access the data for Alaska. So, if you already roughly remember the data come from USGS, and then I can do it this way: data doc USGS, and then underscore gap, something like that. Hit enter. So basically, it's just a string. So just basically, we're getting the social security number, but I don't know the full 9 digits. I just remember the first one, and then it will auto complete the rest of the numbers. So this is one way you can get the data set. And once you have the data set, you can get the metadata. So this is similar to what we earlier we searched using the toolbar. So it'll be similar to this one. For example, click here, data, and I can search, for example, if you want to find any data for Alaska, right? Just search it, and then you'll be able to see all the lists. For example, this is the one we're showing here, and you see this metadata within this interface, but you can also call a function to display it if you want to. So this is searching the data, look at the summary, look at the cast of the movie, something like that. So you can see if this is the data that you want or not. Or you can just Google it, whatever data you want, and then at the end, add like Earth Engine, you will get to the find the data set for you. So next, let's quickly go over some of the data types. And this is very important that you need to understand the data type, what data type are available in Google Search Engine. And again, it's very different from local data set. Okay, local, we have a swap file, or GeoJSON, or GeoPackage, or database. We have one image, we have a bunch of images within a folder. So in Google Search Engine, this is the corresponding terminology. Image, EE.image, uppercase, I. And it's basically an object pointing to the data set, but the file size is very tiny. It's a reference, it's not the original. If the image is 1 GB, the EE.image is just a black box. And then when you really do the computation, you grab the data and then pass it to computation. So everything is just a reference. Image collection is a bunch of images. So image collection can be, for example, all the Landsat 9 images from the sensor is one image collection. So image collection can have one image, can have two, can have a million, can have 10 million, it doesn't matter. It's all belong to the same sensor. But you can also put different data together as an image collection if you want to, although not very common. And the other one is here, EE.geometry, EE.feature, or EE.feature collection. So the geometry is just the shape, no attribute, basically just the polygon. A feature is the polygon with some associated attribute attached to that. So a feature is just like one row in a swap file. A feature collection is equal to a swap file, but the feature collection can have millions of lines or rows if you want to. So let us read data type. So let's look at the first one, imaging here. And like I said, EE.image, and then passing the unique ID, basically the social security number to the image. And then you can just print out the variables. So this one shows you in here. So you can look at, for example, this image. So every Google Search Engine object, you can just type the name of the object, and then it's going to show you the attribute. So this one is an image. This is the ID, and what's the bank in there, and the coordinate information, properties, something like that. You have the links, so you can read all the information. This is kind of like you are loading the image to ArcGIS Pro, and then you right click, and then properties, you see a bunch of spatial information, pixel, the cell size, the spatial resolution, the time, metadata, something like that. So you can do the same thing. So you can change this one to anything, okay? So this one can be any ID you get. For example, earlier we look at the, again here, look at this USGS Alaska land cover, right? I can copy and then come back to here. Then I can just replace it. And then Control V, run it, and you can see the same thing. Of course, you can go to the website to check it. It's up to you, but sometimes you just want to do everything within notebook. Then this is the way to check the property, basically the metadata. And this is how I'm going to visualize that. We already talked about this earlier, right? Create a map. So all the workflow in Google Search and Gmap is the same thing. Create a map, pointing to the data, whatever data you want, and then specify the visualization parameters, and then add the layer to the map, display the map. That's it. And then you can continue to add more data layers, just like you open ArcGIS, you drag a data layer, and then you change it. But those are more like using the interface. We're doing the coding, so everything is precise. You have precise control about what you want. And similarly, right, I can just remove this one, and I already showed you earlier, right? You can change it to terrain, then you will change to terrain. So just m.add layer. So the m.add layer function can add any Earth Engine stuff. Can be image collection, can be feature collection, something like that. And similarly, if you want to see the pixel values, right, I can hover my mouse to this toolbar, and then click this one, and then you can click on the map. You will get the pixel values. So same thing like what you can do using the JavaScript code editor. So this is one. So next, let's talk about image collection. So we're going back to earlier the question, how do I find the images for Indiana? And then cloud coverage is less than 10%. And images acquired last year or last summer or last winter, whatever you want. You just need to figure out the criteria, and then Google Search Engine has loads of functions to help you filter the data. So next, let's look at this one. Image collection. So we're going to use the Sentinel-2 surface reflectance. Again, you can just copy this one and then paste to Google. You will find more information about that. But let's think about how we can actually filter the data. So look at this one. So let's so here earlier when we create a map, if you remember, this is the coordinate for this hotel, latitude and longitude. So if you are interested in doing the taking the images for this location, then you need to figure out the latitude and longitude. And keep in mind, there's some confusing in here. So let me go back to this one. Maybe create a map here first. Gmap.map, and then put the center equal to the latitude and longitude. So when you create a map, it's latitude and longitude. Google uses a different convention. It's longitude, latitude. So you need to pay attention. Sometimes you get weird results. So I'm going to copy this one here. Okay, Control C, and I'm going to paste in here. But make sure that you switch. Otherwise, you're going to get weird results. Okay, so it's latitude first, and then longitude, and then I can set a zoom level, for example. Oops. Comma, zoom equal maybe to 10, I'm not quite sure, and then create a map. Okay, not so bad, right? Michigan City here. And so next, let's figure out how to actually find the imagery, right? We're using Sentinel-2, I'm going to find the images. So in Google Search Engine, you need to create an object. So like I said, if you want to filter the data, you cannot just pass in the latitude longitude. You need to create an object called geometry. This is called e.geometry.point. And then leaves basically the longitude, latitude. So it's the reverse. And so this one here, collection dot filter bounds. Filter bounds basically the filter by location. So what we're doing here is that, okay, the entire Sentinel-2 image collection, give me all the images intersecting with this point. It's called filter bounds. And then show me how many images, right? So let's run this one. Take a look. You're going to take some time because the Sentinel-2 is pretty big. And I'm going to show you, okay, it has 1,584 images covering Michigan City, this location. And then you can just look first. Look first is going to get the first imagery, make your criteria. And then you can see the metadata, right? So this one is Sentinel-2, 23 bands. You can look at the property. You can also look at the dates in here. So 2018, March 14, right? So you can see that from the name, but you can see all the properties. But it'd be nice that we can visualize that, right? So we are just showing you how to narrow down, right? You have all the images. And then let's look at the next one. So even better, okay? Filter by, get all the images in for Michigan City and get all the images for last summer. For example, you can say filter date. So here, basically, you're having a composite criteria. Filter by bounds, basically filter by location first, and then continue to filter by date. So what I'm showing here, this is the start date and the end date. So 2023, July 1st to September 1st. September 1st is excluded. So the ending date is not excluded. So basically, it's July and August. And also the other one here is the filter. This one is a generic filter. So you can, in Google Search Engine, everything is an object. So you can create a filter object. LT means lace length. Okay. So what we're doing here, image for Michigan City, last summer, cloud cover is less than 5%. So you might be wondering, how do I get this one? How do I know this the property? Yes, from here, from the early one I show you, the image property. So each image has a property called cloud coverage percentage in here. So for example, the first image is 26%. It's not so good, so I don't want it. So that's why I narrowed down the criteria. So now look at this one. So we have all the criteria. You run it. And so earlier we had 1500, but now it should be much smaller because you only have 8, right? So this is how you narrow down the images from a large collection to find the image you want with high quality covering the area. And with that, now we can start visualizing it, right? So again, creating the map, and this images right now contains 8 images. Okay, so what we're doing here, I just want to see the first one. So images doc first is getting to the first one, and then you can do the visualization here, minimum, maximum, the bands, and add the data layer, and then center the map automatically at the center. And take a look now. Oh, you want the second one? Yes, we can do that as well. Yeah, it doesn't work here. I will show you how to do that. But like I said, this is the first one. Look at here. Right? We don't download the data. We just filter the data, and then we get it. We see it. And then you can, again, we haven't done computation yet. Right now, we're just searching the data. So the equivalent way of in the past would be you go to the European Space Agency, sign up your account, log in to search the data. Yeah, and then download a couple gigabytes to your computer, and then use desktop JS to visual. But now, look at this, seconds. And the nice thing about this, it doesn't matter what location, it doesn't matter what time, it can be anywhere. You can do it for Chicago, you can do it for Tennessee, you can do it not just for one image. I can create a global composite, just one more line of code. I can create all the data for example, for Indiana for last month, for last year. Same line of code without even change anything. So this is the first imagery, right? So earlier you mentioned, okay, how about the other images? So because this is image collection, and in here, we're getting the first one, you cannot just say like curly bracket or something. So it's a little bit different. So in here it will be images to list, because it's image collection. We're turning it to the list, and then we're getting the index of something. So again here, this is something that is very different from desktop that you can, oh, I have a folder 8 images, I select the second one. In Google Sensing, you need to basically change the data type. So it's a little bit tricky. So to list, and then you'll be image.size. Basically, we are turning those 8 images into a list. And then at the end, I can just get. So here will be, for example, you want the second one, you'll be index 1. So Python index starting from 0. So 0 is the first one, and then 1 will be the second one, 2 is the third. So for example, we are getting the second images from the list, and then let's see if it works. Okay, it doesn't work, then you need to turn this one into e.image. So this is where, if you're new to Google Sensing, this is something that you might having a hard time understanding what this is doing. So like I said, everything is a black box in Google Sensing. So you need something to explicitly convert it to the object that you want. So now let's try this one. It should work now. So what we're doing is turn those 8 images into a list, and then say, I'm going to get the second one, and then get the object. Google Sensing doesn't know what it is, and then it's going to go back to turn it into an image. So see this? So now we have the second one. Right? And you will see the images doesn't cover the same location because of the different thing. But we can have other criteria to do that if you want to. But you will see here, right, the cloud coverage, you see it still has a little bit cloud cover here because cloud cover is less than 5%. It's what we said. But this is right now the image. We already have the pointing to this image. So if you want, you can see the properties. So I can create a new code block, and same thing here, just type image, Alt Enter. You can see all the properties of the image, basically the metadata of the image. And sometimes you might take a couple seconds because again, it has tons of images. It's pointing to that one, you need to grab the data. So here I can click and then properties and look at the cloud coverage. Okay, 1.3.5%, right? It meets the criteria. So it's up to you what you want to do. So this is easiest way of getting that one. And next, let me quickly maybe, like, let's say, okay, you have 8 images. Can you give me a composite of those 8 images? Good quality? It's actually pretty simple. So you'll be like this. Let me show you. Again, this is a little bit awkward, but you get to that result. And if you want to get a composite, it will be like this. Images, all the images, and then you just apply a median filter, M-E-D-I-A-N. Median means you have all the images. So every location, you might have 8 images, you might have 6, you might have 5, right? Because the images is not covering the exact same location. So the median is basically taking the median pixel values of all the bands. So for example, band 1, I'm taking the median pixel values of all the band 1, band 2, so basically time series. The reason we're taking the median is because remote sensing, if a cloud coverage is with white color, the value will be really high. If it is very dark, the value will be very low. So median is usually pretty good. So it's somewhere in the middle. So you want to end up with an image because we all, oops, is it? Or maybe not this one, because it's what's they call? It's a center object. So this is a computing object. So you might not necessarily have that object getting the unbounded. So all the computation in Google Sensing, when you're doing computation, it doesn't compute just on the image. You will compute usually at the global scale. So sometimes it might be a little bit tricky. So I commented this one out, but look at this. You can zoom in. And this one here, this combine all the 8 images together. And just a simple median mosaic, and look at it. It's pretty much cloud free. And you will see some artifacts in there. It's not perfect, but there are better way of creating the cloud free mosaic. Right now we're just doing a simple one. So look at this one here. How many lines code? Just 4 or 5 lines code for Michigan City. You can do the same thing for the entire state of Indiana. You'll be pretty much the same line of code, except here, rather than using the geometry as a point, you can use a bounding box, and then you can do the same thing. We'll show you more examples later, but for now, just use this as an example to how to filter the data by date, by area, and also by the metadata. It can be cloud cover, it can be anything else, anything in here, any property in here. You can use that to do the filtering, because, for example, you can say cloud shadow coverage or ID or anything. So all you need to do is to change this one here, either filter to this one. So less lane, or if you're someone you're doing cloud resource, you just want images with a lot of cloud, then you'll be LT changed to GT, for example. Cloud coverage less than 80%. Let's try it out, see if we can do it. For example, GT equal to 80%, and let's see what happened, right? So I can do this again. You should be able to get all the images last year. Okay, we have 14 images, and same thing right now. Maybe I just do the first one. Okay, and then turn this one back on, and you should expect to see a very cloudy image. So everything is very flexible. You just need to know how to use the source code to help you find the data. Although it might be a little bit slow, because again, it's going to the data catalog and you're going to find the data. Yeah, of course, it's very cloudy. So it's up to you what you want. This is not usable for us. So, and just to show you the flexibility of precise control about what you want. All right, so this is about getting images. So it's the same thing. You can do it for length set. You can do it for modis. You can do it for any data set. The mechanism is the same. Filter by location, filter by date, and filter by metadata. And so next, let's talk about vector data. So how do we filter the vector data? So we already have this one earlier, for example, not this one earlier. So right now we're loading the USGS, the Tigers raw data set, and this one is at the national scale. And this is a huge vector data set. There's many gigabytes. You see, it's going to load the data. When you zoom out, you cannot really see it clearly. And so how about this? I just want all the rows for Indiana, right? So if you're doing some transportation, you want to get all the rows. Now we are loading the data here for the entire US. And so what you can do here is to figure out how to have filter. So you're pointing to the entire image collection. So both the image collection and filter collection has this filter doc message, something doc filter. And then we're going to pass in the filter. So the name equal to Indiana. That means we're getting all this. This is called select by attribute. If you use ArcGIS, QGIS, you're probably familiar with that. You load the data layer, and then you open the attribute table, and then you click like select by attribute, and then you double click the row column name equal to something. Same thing in here, but using coding. So now we run this one. Look at this. Oh, this one is just we are talking about the state boundary. We're getting the Indiana state boundary, right, for the entire state. And then we can do the intersection. And then we select by location. So here, look at the first one. So this is just look at the property of Indiana, just like you are when you are clicking the polygon. And after that, you can turn this one into a data frame. So this is like in Python. If you want to see kind of like the attribute table, similar to in desktop GIS, you right click, open the attribute table, you see that row. So the E to DF is basically converting the Google Sensing object to a data frame. And so here, let me show you, right? Let's come back to this one. So earlier I showed you this was the Indiana polygon, and this is the Tiger dataset for the entire state. So if you just want a small section, we can also do the filtering. So let me come back to here. I will say F, or I can in here, dot filter. You can type any name, filter bounds, and then parentheses. So this you'll be passing Indiana. But of course, this one, Indiana, we are having down below in here, so it's not very good. So I can maybe change the name here, INDIANA. Maybe let me copy this one. I'm just showing you how to filter some of the vector data. So I can come back to here, Indiana. So you have the rows, you have Indiana, and then now I can say, oh, it needs to be at the top. Sorry. And so here, filter bounds will be filtered by Indiana. And again, it's going to be a little bit slow, but if you zoom out, you'll be just for Indiana. You will not get data for other states. So this is how you can filter data easily by attribute. And this is huge data set. It's going to take some time to load up, but like I said, figure out what data set you're going to use, and then you can narrow down to select the data set you want by location, by attribute, by date, by time, whatever you want. Yes, but you don't want to have too much because this one has thousands of rows. Yes, so you can export to panel. So for example, here right now you see here we have all the rows, right? I don't know how many, but I can look at the first couple of rows. So you'll be here, you create a new row. I say gmap dot e to ef, right? And then so this should be the fc dot maybe limit 5. So I can limit to the first 5 and then just run it. You should be able to see the data frame of all the first 5 rows in Indiana. It's going to be slow because don't think about the data set is huge and you're trying to get all the information to display on the computer. Kind of like you're watching a movie on Netflix, high definition, and it looks very clear, but if you ask Netflix, okay, give me the movie, I want to save a copy. It's going to take some time, but you can get a close resolution. So here, you see, I show you the first 5 rows, and you can retrieve that easily, turn it into a table, just like in a ArcGIS data table when you right-click to see it. So that's about the vector data. We have a couple more here for the filtering. For example, you can filter multiple states, right? So this is the state boundary, and like I said, the filter, something to filter is a very powerful function. So you can filter anything by date, by location, by property. So this one also has the e.filter in list. That means if the name is in one of these lists, I select it. Okay, so for example, I want to do research on East Coast, West Coast. You can do something like this, or I can change it. For example, I just want data for, I just want the state of Indiana, and I also want maybe Ohio, right? Then you can remove this one and then just run it. Then you will select just for that, right? So this is so-called select by location. It's very flexible. And similarly here, you can turn this one into a data frame if you want to. So it'll be same thing here. Look at the name. So this is called FC, the feature collection. Then it will be gemap.ee to EF, and then just FC. if the data set is pretty small, it should be very quick. So in that way, you look at all the data columns of the vector data. And you can also filter by location. So let me show you this one here, right? Look at the map, and I can draw a rectangle. So for example here, just click the button. And so this is so-called select by location. So earlier is select by attribute. But now I can draw a rectangle somewhere here. Right? I want to select all the states intersecting with this polygon. You can do that as well. Just run this one, select it. And see, so now I have all the polygons intersecting with my geometry. So it's up to you what you want. If you're writing code, usually you want to hard code it in your code, but if you want to do that interactively, you can do it this way as well. So this is about how to filter the data. So vector data, you can select by location, select by attribute. Image collection, you can usually select by filter by location as well, by date, by metadata. So, and you can apply to any vector data. It doesn't have to US state. You can be, for example, you have a building data set for the entire US. You can filter, I just want a building for Indiana. Then just the feature collection doc filter something. So there are a lot more other functions available. So I recommend if you go to the Google search engine and then go to the code editor, for example, let me show you here. So basically, how do you find out what filter to provide? Like what kind of filter available? Either filter the less than, greater than, greater or equal than, something like that. How do you find out? If you go to the Earth Engine code editor on the documentation here, on the second tab, oops, everything's in here. So if you go to e.filter, these all are all the filter available. We are only using two of those, right? E.filter greater than, you just click that, you will see the functions. And so e.filter, for example, by date, by calendar, by something like that. So you might be doing research, for example, I want to get all the summer images for Indiana. Then you'll be doing this way. E.filter calendar range. And then you'll be, for example, 7 to 9, right? July to October. And then the field will be months, right? Or quite in summer month. So everything is flexible. You just need to know how do I get there. Using this sum of filter to narrow down and then eventually get the result of what you want. And you can also do the search in here, for example, right? ALT, you will find all the algorithms, anything contains the ALT function. So kind of like a API reference that you can search data. Okay, we have 10 more minutes. Let's get to the other portion here. So in terms of visualization, we covered some of those earlier. So by default, if you don't know how to visualize that, the easiest way is just pointing to the data, and then just use the map.add layer and giving a curly brackets, and then in this way is just by default is just a gray scale color, a little bit transparent. But if you want to visualize that, there is a function here. Doc style. So for vector data, it's something doc style, and then you can provide how you visualize that. So here, let me show you, right? So this couple lines of code, this is where you control what you want it to look like. So for the vector data here, you have the outline, the outline color. You have the width, basically the line width of the polygon. You can also have the fill color, the inside. So as I mentioned earlier, look at this one. This one is 8 digits. So 8 digits will be RGB and then the opacity. Okay. So the first two is the red and then green and then blue and the opacity. So the opacity here, these last two digits control the opacity. So if you want to visualize the polygon without filling the polygon, then it can be anything. 0, 0, 0, 0, 0, 0. And then the last two digits is the most important. 0, 0 means it's fully transparent. So if I run this one again, look at it. It's transparent. So how about I want to fill the polygon with green color? You know what should we put in here? Green color. Like red, green, blue. So green means like if you only fully green, you'll be, what should we put in here? FF, because the hex color code is 16, so it'll be fully green. Oh, it's transparent, so you probably need to change this one. Also to FF, that means it's fully opaque, so you're gonna have the green color. If you want to be half transparent, so the half will be roughly 80, so it'll be half transparent. So it's up to you what you want to do. Everything is precise. You can have precise control about what you want it to look like, but you do need to provide some coding. For example, I want to change the width to maybe about 5. You'll be a little bit thicker. The line will look like this. And again, the vector data is in the cloud. When it's rendering on a computer, it's just PNG. You are not accessing the original data. The data is still in the cloud. And so this is how you visualize vector data. There also are different ways in here. This is a little bit more complicated, but you can create correlation maps to color by a column. So look at this one here. We have the collection, and then we have the visualization parameters. We provide a color palette, and then there's a function called X-style function. So you're going to basically add the vector data. I want to use this column to color the data, and this is the color I want you to use, and this is the name, and then you can pass in all the visualization parameters. So what this one is doing is you have 5 colors, and then it's going to order it alphabetically by the state name, and then you're going to see the color like this. But you can change it to others. So for example, you can be lane area, you can be any attribute. So kind of like in desktop.js, you load the data into desktop.js, you open it, and then change the symbology. You select the field, the column name you want to color, and then you're going to generate. So this is a little bit more complicated, but if you want to try it out, you can do all kind of other stuff. So this is for filtering the data, vector data, raster data. So basically, I show you how to search a movie and how to watch it and how to narrow down to the movie that you want, what episode you want. And up next, we're going to show you a couple more tools. We're kind of behind schedule, so there's an exercise in here. You can, you can work on it after the workshop. So be pretty straightforward. So you can basically search any data set you like, and Landsat, Sentinel, search anything from the data catalog, and then you can find the data for your area, for the region, and for specific day, and then with all kind of metadata. So the next example I want to show you here is the plotting. So this is useful if you're working on remote sensing. You want to see the spectral signature, right? So we are loading. So now it should be pretty straightforward. Like create a map. We're pointing to this Landsat data. This is how I'm going to visualize that. We are pointing to another hyperspectral data, filter by date, and then visualize that. So now we have these 2 data layers. And we are adding a so-called plot GUI. So basically the plotting the spectral signature. Once that is loaded up on the right here, you can select data layer. So we have 2 data layers, right? You can just hover your mouse on the map, just click that. You'll be able to see the spectral signature of the imagery, right? I can click on the water. You will see the water. You will see the so this is only we have 6 spectral bands for the Landsat data. So you can click anywhere. And you can also do it for hyperspectral. So the other layer is hyperspectral. So you can click this one, and those strips like gray color, gray scale color, this is hyperspectral. So I can click that. You're going to get the hyperspectral signature. And it looks very crowded, but you can change the property. So for example, I can run this one to set the options, and run the other one at the color marker cluster. So now if I run again, click again. So now basically what the spectral signature look like, you can customize. It can be a bar plot, it can be a scatter plot, it can be all kind of a type. And I can click somewhere else in here. Right. So if someone want to see the data, for example, look at the pixel value, this can be something you can try. So this is the spectral signature, and also have legends, for example. Legend is something that, like when you create a map, you might want to show add a legend. So this is the NLCD lane cover, right? So we add, this one is not Google changing, but what I'm showing here is the map.add legend function. So Gmap has some built-in legend, for example, NLCD and some other lane cover types. So all you need is just add a name, and then you will show it up, show update on the upper right here. And so in this way, you can easily find the corresponding lane cover type for this one. So just makes it easy for you to interpret the data. And similarly, this one is using Google Sensing data. The map looks exactly the same. The difference is that the earlier one using the base map, you cannot get the pixel values, okay? This one is Google Engine. You can get the pixel values. So for example, I can zoom in here, maybe full screen, right? So this is NLCD, and here show you the legend. Again, I can, if too much space, you can expand it. And so now I can click this inspector button. And so for example here, what's this brown color represent? If you don't know, click it. You see the pixel values, 82. Okay, what is 82? Cultivated crops, basically agriculture, right? You can click somewhere else. For example, here, forest 42, evergreen forest. Right? So it's just like you can have the data, you can have the legend to actually help you interpret the data. And if it is too much, you can hide it. You can expand again. Same thing here. So all these widgets is what Gmap is about. It's to help you visualize the data, help you get the data, help you interact with the data. And let me come back again here. If you're working in Google Colab, this full screen button will not work. Okay, so don't try it. If you keep clicking, it doesn't change anything. So that's the limitation of Google Colab. And you can do some customization. So for example here, again, this one is same thing, the same map, but you can customize the legend. So you can add a legend by yourself. So if you, for example, you do some use lane cover, you create a lane cover, and then you want to assign a color to different map, then you can do it in here. So a dictionary basically is the label and also the color. So look at this one here, right? So you have open water 11. If you want to change it, you can change it, right? So for example, I want to change it to just water. Then run it again. Then we have water. So this legend comes from that dictionary that you customize. Although it looks very lazy, the code, but it's pretty straightforward. You define what you want to show on the map, and you will create a legend for you based on your customization. So again, this is the hex color code. I'm going to show up. So you definitely need to have that. For example, you want to change it to blue color. What's the hex color code for blue color? 0000 FF, right? You see now it's blue. But of course, your map need to also have the blue color. What I'm saying, showing you here is just everything is customizable. You just need to know how you want to set it. And besides the legend, you can also have a color bar. So color bar is more for continuous data. For example, elevation, temperature, soil moisture, wind speed, whatever. And the color bar is the one here looking like lower right corner. And so it's being added just with this one line of code. Map.add color bar, and whatever visualization you use to color the map, you can add it. And then you can have a label. So the label basically is the one at the bottom here. And also you can provide the layer name. Then the color bar is linked to the color bar is linked to the image. So if you turn the image off, the color bar should be off as well. Right? If you don't put the layer name, you'll be there all the time. Right? So the nice thing about this is that I can change it. For example, right now I don't like this color palette. I can change it to, for example, terrain. I don't need to change anything else. The color bar grab the premise. Oops, grab the premises from there. So look at this one. You see, it's updated. So for those Google Engine users using JavaScript, see how many lines of code need to write to create this one. It's not simple. This is simple. It's not one line of code. And you can make it vertical. Okay, change to vertical. If you don't like the background, you can change it to be transparent. Come back here, transparent. So super easy to do. So this is why you sometimes might use Python. It's just a lot of things are very, very simple right now compared to JavaScript. And a couple more. Split map. So this can be useful if you try to create data layers. You want to compare them side by side. You can create a so-called split map. And right now we're just using the base map. For example, I'm comparing data, for example, for two different base map layers, like all terrain data layer. And this is not Google Engine. Next one here, this one is Google Engine. So again, we are pointing to the NLCD lane cover 2021 and 2001, and then select just the lane cover band. And then we turn this one into a layer, and then you pass in this one into the split map. And now you can see here, right? We have two data layers. We can compare them side by side. I can zoom into the famous last figures, and you can see the changes. Right, so the one on the left, this one is 2001, this is 2021. Right, how cool is that? Again, this is just two to three lines of code, and it's very simple. Again, if you're trying to do that in JavaScript, good luck. It's a couple hundred lines of code just to create this simple split map. And this is super easy. So basically, you can point to any data layer you want, and then just passing the data layer to the split map function, and you can visualize that easily. And this is not just visualization. You can do computation. You can clip. For example, I just want the image clip to a certain area. For example, I can just run here and then just say clip to a certain region. For example, let me show you here and say m equal to image, maybe not a good example. I say m1 equal to gmap.map. Okay, then m1. So for example, I want the image just for let's say for the state of Indiana. Okay, you can use the feature collection that we get earlier, or I can just simply I just want this one somewhere in here. And then what I can do here is come here to just say clip. I clip the image to m1.user_ry. Same thing here. So clip. And then m1.user_ry. On it. So now you should just have that one here for the area, right? So all the data I can clip on the fly. You don't have to download the data. You can do whatever you want. And now I can see the lane cover change for step Indiana. You can do computation. We do the computation this afternoon. Just show you, for example, what's the urban growth, what's the agricultural change, or anything. So you can do that for very easy, just one line of code. You can get the result easily. Next one, link maps. This one probably doesn't work on Google Colab. So if you try to run it, it may not work. But I'm showing here, this one looks very complicated. But what it's doing is that you can show multiple maps together. So you can compare data layers side by side. I'm not sure why it's so slow. Probably when the data becomes much larger, it's going to be a little bit slow. But here shows you side by side. I can display the imagery in different bank combinations. So this is in Michigan City. So I can zoom in. You see, you can zoom in all the line. So sometimes if you want to try to find out, what's the base combination to visualize a certain feature, whether water, vegetation, whatever, you can do it like this way. So again, probably doesn't work on Google Colab. That's fine. You can just see this example. And we have more time. What time? Oh, we already passed the time, 5 minutes. I will stop here. We continue this afternoon. So we have a lot more features to show you. So this afternoon, we'll do a lot more analytics. So far, we have only covered how to stream the data, read the data, but there are a lot more to come. So I will see you this afternoon. Thank you very much. I hope you learned something new. Say it again? Yeah, starting at 1. So you can go get your lunch. Okay, can you hear me? Let's continue. So we are a little bit behind schedule, but that's fine. You have the entire notebook. So if you cannot finish, you can try it later after the workshops. And for those of you who close your notebook, if the notebook is gone, if it doesn't connect anymore, you can open it again. So let me go back to the beginning of the notebooks. So you want to go to, anytime if you start a new notebook, you need to import the library again. So, and also keep in mind, it's a very long notebook. So you're going to generate a lot of maps. And from time to time, you might need to restart, clear all the outputs. So it's clean again, so you don't have a lot of things at the beginning. So what I would do would be, if I on Google Colab, you see, right now it's asking me to log in. Let me see here. You see, it shows disconnected, so you need to sign in again. And most likely it'll be a new notebook, so you might need to reconnect. And you might need to install the packages again if this like disconnected. So also from here, the runtime, you want to try the restart section to clear all the outputs. So locally on my notebook, I would do this kernel and restart kernel. So it's the same thing. They just use different terminology. And then like restart. Then I can import the library again. And also I can clear all the outputs. Edit, oops. Clear say outputs. And then run this one again. Clear output all cells. And then initialize again. See the map. So as long as you can see the map, you're good to go. Then I'm going to skip back to the time series inspector. So what we are showing here is showing you different ways of visualizing the data. So we can view the data layer. You can add the legend, color bar, but this time series inspector is useful if you have a bunch of images. You want to sort it all in once. So run this code block just to see what it looks like here. So we're accessing the NLCD lane cover data set from 2001 all the way to 2019. This is for the coordinate scale, so for the continental US. And I'm going to show you here. What we are doing is just one line of code. So you can imagine you have an image collection. The image collection can be a time series lane cover, or it can be a time series lane set data, same thing or whatever, basically a bunch of images. And then you can just call in this function called TS inspector. And what it's doing is you give the image collection. So you can basically, it's a split map, one on the left, the other one on the right. And so in this way, we are using the same collection. Basically, I have the same amount of images on the left, the other one on the right. But the nice thing is that it allows us to have a drop-down list. So we have the 9 images, so now you can easily change, right? So rather than loading all the images as individual layers on the map, you're going to have 9 layers. But in this way, we can just have 2 layers, one on the left, one on the right. So, and now you will have this split map, right? You can change anywhere. So let me zoom into the, the Las Vegas again, for example, right? Let me zoom this one a little bit here, right? So now you can see left and right, 2001 and 2019. You can select the drop-down list. I can change it to, for example, 2011. You see the changes, right? Do you notice that on the left side? You can change it on the right side as well. It's up to you which one to change. So this basically gives you an easy way to visualize a bunch of images. It can be original satellite imagery, it can be lane cover, it can be forest cover or anything. As long as you have a bunch of images. And it's pretty good if you want to see the changes. You can also do, I have the satellite images on the left, I have the lane cover classification on the right, and then you can just compare side by side. So imagine you have 9 satellite images, lane set, you have 9 lane cover classification, and rather than having to write the code, load this data layer, load the classification, load this, you can end up with like hundreds of layers. This one is only 2 layers, and then you just change it side by side. So for example, I change it to 2016, and not much change, but you can see some slight differences in here. So essentially, it's one line of code. So give me any image collection. So a bunch of images, and on the right, if you can use the same one, but you can use another image collection as well. And then you can give it a name. So the name basically is all the years I have, and then it's going to filter the data based on the year. And the right is the same, and then this is how you're going to visualize that. Basically, is the parameters. So similar to how you visualize a single data layer, but we are visualizing a lot of data layer all at once. So this is so-called the time series inspector. I will show you more examples later how to do that. The other one is the time slider. This one is not the split panel, but it's acting a time slider to the right. So again, look at this one. There's a slider at the bottom. So same thing. This one we're doing the modis lane cover, and it's daily image. Okay, from 2018 June 1st to July 1st. So basically, you have 30 images. And if you want to see all the images all at once, you need to add 30 layers. It's just too much. So what you can do is use this time slider, and all you need is just an image collection. And then you can specify how fast you want it to be. So let's zoom in here and look at the imagery. So this time slider allows you to drag the time slider to a certain date. For example, I want to see June 9th. I want to see June 16th. Right. So when you change the slider, you're going to, based on the date, it's going to grab the imagery and they display it to you. You can also play it, but it might be a little bit laggy. It depends on the internet. So I'm going to skip through, show you the images one by one. And I can pause it. You can also close it if you want to. So basically, these are the two different ways of visualizing time series data. Instead of showing all the data layers into the map all at once, here you only get the data layer of your chosen specific day. And you can specify how you want to change the symbology in here. So look at this one here. Right? So this line of code, if you don't want to use the time slider, you'll be, let me comment out this one just to, so how do you show just one layer, right? So previously, if you remember earlier, we saw the first image, for example, right? So you'll be m dot add layer, oops, right? And because it's image collection, so it's a bunch of images, we can say collection dot first, right? We saw the first image, and then you'll be your visualization parameters, okay? And then the layer name, for example, first image, right? So this is the traditional way you visualize one image, right? So look at this one. Not much changes, right? It's the same. You give the entire image collection how you want to visualize that, and the time interval is how fast you want the to play. So 2 seconds means from one image to the next one is every 2 seconds. So that's why if I run this one again, oops. All right, so now I can click the play button. So every image is going to stay 2 seconds and then go to the next one. But the function parameters are very similar in here. So you can easily customize it. Again, just give me any image collection. It can be one image, it can be 10, it can be 100, it doesn't matter. So you can use this one line of code to do it very, very easily. And this is for vegetation. Next one is same thing in here, right? It's using, for example, temperature. So this is temperature data for 24 hours. So 0, 0, for example, and then you just click this one. So you can see the temperature changes for 24 hours. And pretty much just a couple lines of code. And look at this one. Same thing, just using the time slider. And the label basically just show you the to reformat the label as 0, 0, 0, 1, 0, 2, 0, 3, something, so on and so forth. So in this way, you can visualize time series data easy. And next one, this is more like optical Sentinel-2 data. So similarly here, now you should pretty easier to understand this one, right? So the Sentinel-2 data, and I want to filter by date. So this one actually is Michigan City, where we are right now, right? So the latitude and the longitude, filter by date. We have covered this one earlier. You can filter by the cloud coverage, and you can also filter by the calendar range. So this is what I'm doing here. I'm showing you how to filter all the data for Michigan City for the summer seasons, right? From June to July. And cloud coverage less than 10%. I don't know how many images. If you want to see it, you can see how many images. So, for example, we have the collection right now, and I can add a new code block and just show you, for example, collection block size, and then you can see in total 106. Okay, so there are 106 images covering Michigan City with cloud coverage less than 10%, or quiet during the summer, right? And how do we actually quickly see it? Sometimes you might want to see the images before you're going to, like, I want to use this one for my analysis. And this time slider allows you to see all those 106 images by date, right? So this is the first one is June 2nd, 2019. I can drag this one through to whatever day you want. It's going to take a couple seconds to load the images because this is pretty big. So now you see images all pretty good. A little bit cloud coverage. You can change it to, for example, to the latest one, 2023, August 30, right? You might still see a lot of clouds, so you can change the cloud coverage if you want to. So this gives you where basically now you can search anywhere, any location, anytime, any summer or any winter. It depends on what you want, and then just see the images, see what it looks like. And this is different from you go to the USGS, you see the data, you are only seeing the thumbnail. This one you are seeing the original image. So you can zoom in, it's pretty high resolution. Right? When you zoom in, it's going to load the data. It's going to become clear and clear. Right? So now, if you give a task, for example, find the hometown of your, the coordinates of hometown. and just look at all your images for your hometown, something like that. So for example, I want to come here, I want to see, this is for Michigan City, for example. I want to see that for Knoxville, right? I want to see how many images covering Knoxville. So I can just come here, look at this one, and all I need to do, just simply, you can just place a marker somewhere. For example, this is Knoxville, okay? And then I just get a coordinates. So click this one, and then it will be m dot user ROI, okay? Maybe coordinates. So you have this, and that's it. So as you can just copy, or you can just a simple, maybe just latitude, longitude, latitude, copy, and then you can come back to here, right? All I need to just replace this one. Control V, that's it. So now I'm doing that for Tennessee. Of course, you need to change this one as well. Zoom to location and run it. Calendar range, yes, here. Zoom to July. The last one is not included, excluded. So if you want to zoom to August, September, then you'll be zoom to October, for example, then you'll be 6/11. No, it's not average. You are getting the original image acquired during that time. So filter by calendar range, for example, I want the image for summer. Then depends on which one to count summer. For example, 6, 7, and 8. Yeah, you can see all that. So for example, right now, see, I'm doing that for Knoxville, Tennessee. And you see, I don't really change much. Just change the coordinates. Everything else remains the same. So now I have all the images for Tennessee. You can do that for Chicago. You can do that for anywhere. And look at this. Say it again. Oh, which year? You need to look into the collection, but here you control the year. For example, you can continue to filter. For example, I just want the images from 2013, 2022, for example. Then you here get another one, dot filter by date, or maybe filter date, and then you can pass in a date in here. For example, I can say 2023. 01, oops, maybe January 1st, and then the end date will be 2024, January 1st. Basically, it's 2023, last day of 2023. And then the same thing. So this, you're going to get a much smaller amount of images. Yeah, so if you don't have the filter date, then we get all the years. So for example, from 2018, all the summers. From 2018, 2019, 2013. So it's all up to you what you want to do. For example, right now it's 2013. You see here, the first one is 2013, June 23rd. And I can just slide through it. You can see how many images. Okay, this one only have 2 images. Okay, only have 1. So that means it's a much smaller amount of images. And you're welcome to customize to anywhere. So this is the power of using cloud computing. You don't need to download. All need to figure out where do I want, and then one line of code, you get images for different area, and you have access to the original image you can use to do all kind of computation. All right, so that's about visualizing time series. So by now, you should know how to search the data, visualize the data. Either it's one image, or it's a bunch of images, or it's a visual collection. But especially, we have covered vector data and raster data. So, and loads of all the data in the cloud. In the next section, we're going to cover how to visualize some data locally, or how to upload your data locally to the cloud, so they can use for some additional analysis. And most of the time, you already know what area you're working on. You might have a small shape file on your computer. You want to use that to filter the entire image collection. You can do that as well. So in this section, we're going to cover like accessing local data and interact with cloud data. So the first one here is from GeoJSON. So I'm going to show you here. This GeoJSON is from stored in the using this URL, but you can also, if you already have a GeoJSON on a local computer, you can also convert to cloud object. So let's just run it to see what it looks like. Okay, so you're going to download the images, download GeoJSON, and then you're going to convert using this function called GeoJSON to EE. So GeoJSON to EE is basically converting a local GeoJSON file to a Google Earth Engine feature collection. So as I mentioned, all the Google Earth Engine data is in the cloud, is server-side object. The data in your computer is not server-side. So it's basically converting that one directly to the cloud. And one thing you need to keep in mind is this function is only good for small amount of data. So if you have a JSON or Sapphire like more than 5 megabytes, it probably doesn't work. It's very only for small amount of data. So the analogy would be you produce a movie, you want to share with your friend. If that movie is 10 gigabytes, it's not like 1 second and then you just share, eject to the browser and then it become available. No. If you have a small thumbnail, couple megabytes, it's okay that you can eject and share. So same thing here. Google Engine doesn't allow you to download a lot of data instantly or upload a bunch of data instantly. But using this way, at least you can convert some small data set and pass into the cloud. So once the feature collection here, right now this one is a cloud object, you can use it to filter all the images, all the image collection. So the FC here, this is the feature collection. This one right now is in the cloud. So all the country polygon that you're seeing here is already in the Google Engine, but it's temporary. So if you close this one, it's gone. So everything is just a temporary object. So this is for a country, and then you can do the filtering. Then you can say fc.filter, and then you can filter by country name, filter by something like that. So you can also convert a swap file, right? So if you have, for example, I'm doing the same thing. I'm downloading a swap file from the internet, and I'm using this function called SHP to EE. So the one that is being downloaded on the left side here, you will see this one. So I downloaded this swap file, unzip it. So this is something you are very familiar with that. Thanks to Esri for this file format. Very creative. They have multiple parts that people sometimes just send the .shp without having the DBF. But you have this one, right? So you have a file on your computer. You can just call this function gmap.shp to EE. And you will turn this one into Earth Engine object. And then you can use that one for computation. So same thing, right? Run it, and then we can add the data layer. So all these things here, map.add layer, this one allows you to add any Earth Engine object. So again, this one is the official, the Earth Engine default object. And then I can use this editor here. Click. I can hover my mouse. I can click it. Use the way to get. Oops. This is probably a bug somewhere. Okay. Countries, right? And you can see the property. You can see this, like USA ISO A3, right? So for example, right now I'm working on just the US. I want to filter the data. Rather than open ArcGIS and then add the shapefile and then select the USA and then export, and then here I can use Google Engine actually to filter the data. So again, I can just come here. Since I already have the FC, right? So now I can create a new variable, for example, USA equal to FC dot what? Filter, right? Filter by attribute. Or can filter by location. So I just say E dot filter, and then you'll be like this: E dot filter dot EQ. EQ means equal to. So this is similar to select by attribute. And then double quotes, right? So here you can use any column to filter by USA. Okay, for example, I can use ISO A3 USA. Then you'll be like this. You only have the column name, ISO A3, and then comma USA. Make sense? So now I have the USA, and then here I can just say add USA. Right? What error do you get? On the Google Colab? Or is it on? Really? Say that, what's the error again? Oh, I see. Okay. Then you can do this. So let me show you. That's why I think at the beginning you need to install the dependencies. So if it, I may miss some of those. So what you can do here, you can just create a new code block and then just %sign pip install pycra, something like that. So installing the dependency, and then just run it. I already installed, so it's not going to install. So for the Google Colab, you should have that, and then just install this one and then run again. It should work. Is it working? Okay. And once it's installing, then you run the SSP to E again. Hopefully it will work. Yes? Okay, cool. So now you see, I have the USA, right? I filter the data. So the reason we can filter it is because it's Google Earth Engine feature collection. It's not a local set file anymore. It's the data in the cloud. So now I can just run these two lines. I can filter the country. You can filter any country. For example, I want, how about this? I want to get the country for North America, for example, US, Canada, or Mexico, something like that, right? So the filter here is very flexible. I can either filter in list, right? And then ISO, USA, and then on the back here will be just a list. Right? I can comma, CAN, for example, I know it's Canada, right? And run again, I should have US and Canada. No? Oh, there's a space in here, sorry. You need to be very precise. Right? So now I have US and Canada. So it's very flexible. You just need to know how do I get there. What function do I use? What class do I use? And like I said, this is all just like Lego. It's just building block. You just need to get one by one. Eventually, you will get what you want. Also, you can do a geodata frame. So it can be GeoJSON, it can be Swagfire, and also geodata frame. So GeoPandas is another Python package for doing vector data processing. So if you know Python, you might already know about that. And so GeoPandas the geodata frame can be converted to GeoJSON, and then from GeoJSON to Earth Engine. So it's the same thing. Here we're just using the GeoPandas to read the web file, and then with that we can convert it to feature collection. So it's the same thing. So just different format, different input, different vector data format. All right, so that's about getting the data from a local computer to Google Earth Engine. And again, I want to remind you again, the file, if it's smaller than 5 megabytes, it's fine. If it's larger than 6 or 7, usually it would not work. So the more complicated of your file, the more likely it's going to exceed the memory. So Google Earth Engine allows you basically all the polygons, basically just points. The more complicated of your file, the boundary, the more likely you're going to have more points, more storage, then it won't allow you to upload. And you want to say payload exceed something like that, then you have to, if it doesn't work, then there are two ways you can do that. You can, using desktop GIS or programming, to simplify the polygon. So the polygon only have a couple points, or you get the bounding box, just 4 points, then usually it's no problem. Or you need to upload to Google Earth Engine. So here, let me show you. If you go to the Google Earth Engine and then go to the code editor, this is where you can upload the data. So in case the data cannot be converted on the fly, then you open your Google Earth Engine and then come here to assets. And so from here, you can new and then upload the swap file from here. So this one, you can upload gigabyte. It basically have more bandwidth. And then you can, once you upload the data set, then you can get the URL and then you can use that in your computation. So I'm not sure if I have any data set in here, cloud data set. Yeah, I may have some here. For example, I have some, let's say Europe, right? So once you upload your set file, you want to generate this one, and you will see the table ID. The table ID is the same thing as any vector data. So this is the unique ID. I can copy this one, then I can come to here, and you'll be just like coming to here, and I can do this FC, or maybe EU equal to E.feature, is it already E.feature collection, and then parentheses, single quote, double quotes, and then like this, and then EU. Okay, so all the data set, there are different ways you can do that. So last data set you need to upload using their interface. Small data set you can convert on the fly. Let's imagine you want to share a small movie with your friends. Smaller one, yeah, I can share right away. Larger one, you need to upload. It's going to take some time because you need to optimize the data for cloud computing. So this is getting data from local to the cloud. Next, I'm going to show you quickly how to get data from cloud to a local computer. So you might generate some data. Yes? Oh, so this one here. So if you upload any data, you have full control. So this is very much similar to you upload files to Google Drive. You can control, you want to share the file just to yourself, or you want to share the file with your university or anyone. So what you need to do after you upload, for example, I can click this one, and then there's a button here, share. And this one here, if you click this one, anyone can read. That means right now I didn't share it, so you will not be able to use my dataset. It's just mine. So if I check this box, then anyone will be able to just type this URL. You'll be able to use it. Or you can also share with the group in here. You can share with a domain, and it can be reader, it can be access. So for example, read and write. So you can, just like Google Drive, you can share a document with another Gmail account, or you can share with the public. So wherever you want to control is the same thing. So the data set can be private, can be public, it can be restricted. Okay, so next, let's talk about how to get it out. Again, same restriction, limitation. You cannot download many gigabyte data just within seconds. But if it is pretty tiny, small, you can get it right away. So this one here, let me show you, right? We are adding the data for getting the boundary of state of Indiana, right? So we're getting, this is the entire US state. We filter the name by Indiana, and then we add the data layer. We center the map around Indiana. So imagine this is what you want. You want to get the boundary out? Yeah, pretty simple. This is just one line of code. E to GeoJSON. And then just passing the object, and this is where the output file name you want to be, and run it. Then on the left side here, on Google Colab, it should be under, if you click this file icon on the lower left corner here, if you click this one, you should see the file showing up in here. In my Jupyter Lab is here. So do you see this Indiana GeoJSON? Double click. You see you have the GeoJSON. It can be swap file as well. It depends on what you want, like E to swap file, SSP. Then on the left side, you might need to refresh it. Now I have the Indiana swap file. It's only small, right? So it's only very tiny, so it works just fine. You can also convert to a geodata frame like this, and then you can display it like this. Only one line, one polygon, so you can see the attribute. I can also just use the geodata frame explode function. If you run into errors, probably on Google Colab, that means you are missing dependencies. Is it working on Google Colab? Not working? Now it's probably saying that they're missing the map classifier or something. Then you add a new code block and just like pip install map classify, and then just run it, and then you should be able to use this one. Yeah, so run it, and then so this file right now you're looking at, this is local file. Okay, this one is geodata frame. This one stay on a local computer, and this one is not a cloud object. It's not a Google Sensing object. You cannot use this polygon to filter Sentinel to a Landsat because it's not cloud anymore. But you can do the same thing. You can convert it back to Google Sensing if you want to. So just like what we did earlier, right? You can do this. You'll be fc equal to gmap dot what gdf to EE, right? And then just GDF. So we are turning this one back to Google Sensing. And this one right now, this is a feature collection. So you can type FC. You should be able to see the polygon. This is feature collection. So you can convert from local to cloud or from cloud to local, whichever way you want. You can also turn this one into a data frame. So E to DF. It's basically taking off all the geometry. Just get the attribute table without the coordinates. So if this is something, sometimes you want to see the attribute table quickly, you can do it this way. And the last one is to turn it to a CSV. Kind of like in GIS, you open the attribute table and then you export as a CSV. Same thing here, I run it, and it should get that one out. And then refresh. Now I have the CSV here. Double click, you should have the CSV. So simple way of getting data in and out for small data set. Okay, large data set, not so easy. So kind of like you're watching like a Netflix movie. You want to have a copy of that. Yeah, you want to take some time because it's free. You want to take bandwidth. So you're going to take some time for you to download. We will show you more methods to download data, large amount of data later. But now this is just for small data set. Questions? Yes. Yeah, GDMA is also very small because it's from the GeoJSON or from the Shapefile, so it's a tiny one. What error do you get? Yeah, so this is the one I mentioned earlier. So you need to install the package if it is not installed. So pip install map classify. Yeah, but you don't really need to. It's just one function to see the map. Like, but you can also use Gmap to visualize it if you want to. So after you install it, it should work just fine. All right, so this is about getting data in and out. And next, let's start really doing some analysis. This is not really analysis, but it's part of the analysis. So for example, you want to extract some pixel values. Imagine you might be working on, let's say, forestry, vegetation. You want to see how the vegetation changes throughout the year, throughout the season. And you have a bunch of points, for example, right? You are working on the field survey, and then you have the locations. You want to extract some information for all the locations. Or can be, let's say I give you a SRTM, the DM. I want you to tell me to get all the average elevation for all the cities in the US and see which city has the highest elevation, altitude, right? It's a simple question. And traditional way, you need to download the DM, you get all the points, you need to process, it's going to take some time, this seconds. You can get the result easily. So let's load some data here just to show you what it looks like. So the same example we have been using, I'm loading a DM, and I'm also loading the Landsat 30-meter resolution global scale. So look at this. Two data set. And next, let's start doing some analysis. The 2DM, I'm also going to download the US cities data set. So if you just run this one and then just load the data cities to the map. So you're going to add, I think, almost 2,000 US cities, all the points in here. So these all three data layers are Earth Engine data layers. So if I turn this one off, take a look at this. It's not fancy. You can make it fancy if you like, but that's not the point. So what I'm doing here is loading all the cities, and I have the DM. Now, and also the Landsat. I want to see, extract all the elevations for all the cities, right? And so let's turn on this DM data layer in here with all the points. So what we can do here is calling this function, extract values to points. This one actually I'm mimicking the Esri toolbox. There's extract values to points. So use the same name, but the idea is that you can pass in any feature collection, any points, and you can pass in another raster data layer. You will extract all the pixel values. Basically, you have the cities, and then basically any pixels intersecting with the point, you're going to get the value. And then just run it, see how long does it take. It should not take very long, but keep in mind this is global scale, so it doesn't matter how many points you have. It can be 100 points, it can be 1,000 points, it can be 1,000,000 points. It doesn't matter. The process is the same, the function is the same. So only thing is your input data might be different. So now you see within a couple seconds, now I have the swap file, right? And it's downloaded to my computer here. Refresh it and dm.shp, right? So once I have that, I can use the shp to GTF just to look at it and run this one. See, here only shows you 10 rows. So actually we have 3,666 cities. I don't know it's that many. So you get the elevation here. Look at this one, state elevation in feet and ID population 2020. The first column, this is the one actually we get from the DM actually, because when you are use the point intersecting with the pixel, so you get the first pixel intersecting with that. You can change the column name if you want to mean or something like that. But right now it's getting the first pixel. So this is in meters, okay? So every city. There's also the shapefile itself has elevation in feet. That one is from the data, original data, not from the DM. But in feet, usually you multiply by 3, right? This is by meter, so 1 meter equal to 3 feet. So if you multiply 3, it should be roughly equal to the one. It's not exactly the same because the DM resolution they use to get the elevation might be different. But I'm just showing you this function can help you get any raster information attached to the vector data. It can be DM, it can be temperature, it can be moisture, it can be wind speed, it can be anything. So the idea is one vector data, point, one raster data, and then extract the information. You can also extract multiple bands. For example, Landsat data. So Landsat, this one here, has 7 spectral bands, right? I can use the same thing, run it, and see how long does it take. So you're going to get all the spectral values. And this can be useful if you are doing some machine learning algorithm. You're trying to build some machine learning models, but you need to extract some pixel values in order to train the model. Then you might need to use the point or the polygon and then extract the pixel values and then attach the label. So again, show this one, CSV to DF. Look at this. So B1, 2, 3, 4, 5, 6, 7, right? And all the pixels. So you get all the pixel values. It's a table. And you can also come here, double click. It should be on your Google Colab folder. And then you can download this one if you want to. So it should be pretty simple and straightforward. Extract values to points. And next one, extract pixel values along a train set. And this can be useful if you are working on some profile. You want to see the changes along a line or something like that, or along a latitude or longitude. You can use this one. So let me go in here. Okay. So assume, for example, I load a DM, and if you can just run the code, you will end a new line. For example, here, this one is a line across the state of California. So you want to see, for example, the elevation. You want to see the changes of the elevation. I can just run this one just to show you what it looks like. So the extract train set is to extract the information along the line. And let's just show the result first, and so that you can understand what I'm talking about. Right? So this one shows you the elevation changes along that line. So you can also zoom in and zoom out if you want to. Double click, it's going to going back. Right? Pretty easy. So this is very interactive. You can draw other lines as well. So for example, if I go back to here, you want to play with it, I can maybe somewhere here, maybe this one. Okay, I can draw a line somewhere here. Oops, here. So if you double click, it's going to stop. And then you can run this code block again. So basically, this one is line equal to map.user ROI. So if you don't draw anything, it's going to use my default line. If you draw anything, you're going to use your line, right? And then I can run again and run again. And the next time you run, it might take some time, depends on how many lines you have. And so pay attention to this one. It should be different now. You see? So it's up to you how you want to do that. You can customize it. You can do the hard coding to specify the line, or you can draw it interactively. And there are a lot of parameters you can customize. For example, it can be by how many segments. So basically, the line is going to segment into 100 segments. So it's going to get the elevation for each segment. But you can also do it by distance. For example, I want to do it for every kilometer. So this one shows you, for example, it's roughly 6,000 kilometers for 1 point. But if you want to say, okay, I want to every 2,000 kilometers, I want to get 1 point, then you can also do it in here. Instead of using the n segments, there's also a distance interval. This interval you can change the distance. For example, every 5,000 kilometers, then you want to maybe do this, Control C, and then distance. Because I know from here it's roughly 6,000. So if you want to get more points, I can do 5,000, right? And then you can change it. And so now it's every 5,000 you get 1 point. Basically 5,000 the mean elevation. And it should be similar to this one, except you're going to see a little bit more points. Right? So now you have the line plot. So it's all very simple and just one line code. And after that, you can export the transact to a CSV if you want to. Then on the left side, refresh. So you should have this widget transact.csv. So now you can get the point. So basically the point, the associated elevation. It can be temperature, it can be anything. So it's up to you what you want to do. Questions? No? So next, zonal statistics. So this one comes from ArcGIS. Okay, I used the term in Google Search Engine. It's not called zonal statistics. Google Search Engine is called reducer. It's very different terms. But what we're doing here, let's load the data set and let me show you. I'll give you some scenarios. So we have the DM. We have the US state boundary. So right now, if I ask the question, which US state has the highest mean elevation? By looking at the map in here. If you have to guess, which one would that be? Which one? Colorado, right? You see it's the white color, so it's pretty clear. And if I ask the other question, which US state has the lowest mean elevation? Florida? Louisiana? Anything else? Anyone? Any other guesses? Delaware? Okay. So I have 3 guesses, then we can find out. The highest one is pretty obvious, right? It's white color, we can see it. The lowest is hard because it's all very dark green color, low elevation. So let's see who's going to get the right answer. And look at this one. Basically, it's just one line of code. Give me a DM, give me a polygon. I can help you get either it's the maximum, the mean elevation, the maximum elevation, standard deviation, whatever. So this one here, the zonal statistics, you're going to give me a value raster. You're going to give me a polygon. And this is where you want to output, okay, the CSV. And the statistic type is basically what do you want to do within that polygon, right? So for each state, you're going to have a log of pixels. So the mean means that we are getting the mean value of all the pixels within a state. And take a look. One second, you get the result. And of course, you can open this one here, see this one, and then where is it? What's the name? DM statistics. Double click. And now you have this one. So you have the name, the mean. So basically, it's the mean elevation. And also, you're going to have the state name to the right in here. And so right now, we're in Jupyter Lab, so it's not very easy to sort the column. In Google Colab, you might be able to double click. I'm not sure if it's supported, but let me show you this way here. Add another row in here just to show you how do we sort the column. So we can do gmap to doc, I think it's CSV to df. Okay. And then you can just passing the out DM stats. Okay. So now I can show this one within the data frame, and here I can just doc, I think sort. I forgot the name. Okay, sort values, and then I can passing the name of the column, so I can sort by mean. All right, so now I sort the values by mean. So look at this one. The mean elevation is 13, and then 14, 15. So what's the answer? Delaware. Okay, we did have one guess. And then US Virgin Island, Florida, Louisiana, right? So actually the lowest one is Delaware. Very, very low, 13. And the highest one, where are the top 3? Colorado, Wyoming, Utah. Pretty close, right? Because you see the map, you will see it around this area. Right? So now you can get a very precise answer. You don't have to guess. And it takes 1 second. And imagine, it doesn't have to be US. I can give you a country polygon. I can ask which country has the highest mean elevation. So basically, which country has the highest latitude, mean latitude. You want to guess? I don't know the answer. You can pass in the country polygon. You can do it right away. One line of code is the same thing. So all you need is just passing the vector data, the virtual polygon. So what you need to change is this one. The one line of code you need to change is here. The DM is the same thing. And you just need to change this country feature collection. That's it. And you don't need to download the data. You can just get the country and then you can get the work done. Next example, lane set. So you can also do multi-band. So the DM only have 1 band, but you can also do multi-band. For example, I want to ask which US state has the highest reflectance in the near infrared band for this lane set imagery, or in the blue band or the red band, whatever. It's the same thing, just donor statistics, passing the image that has multiple bands, or it can be temperature. So imagine you might have a temperature data layer for every month, monthly mean temperature for the US, and have 12 images, 12 bands in that one image. And then you can get a polygon for the state. Then I can ask, which US state has the highest mean temperature for July? Then you do the zonal statistics, you get that one, the July band, or it can be winter, or it can be summer, whatever you like. So again, lane 6 states, then double click. So you should have this one here, open B1, B2, B3, 5, 7, right? So if it is temperature, it will be also B1, but you know B1 is January or February, right? So on and so forth. So it's very flexible. You just need to know what do you want, what answer do you want to, what question do you want to address. So this is zonal statistics. It's about an image and a vector data. Next example, zonal statistics by group. So let's see what's the user cases in here. I have a DM, not DM, I have a land cover data. I have a US state polygon. All right, so this is the famous NLCD land cover. So now if I ask you the question, which US state has the largest area of agriculture? What color is the agriculture? The brown one, right? Agriculture. Iowa, Illinois, right? It's pretty close, right? In this, somewhere in this area, right? And I can also ask which US state has the largest area of forest cover, largest area of urban, largest area of water, anything, right? You can ask any questions. And you will see here, the source code is the same. All you need to do is just do a zonal statistics. You can get that for every land cover type. So we load the data layer and then look at this one, zonal statistics. So just give me the land cover data, it's a categorical data, and give me the state, and then run the zonal statistics. And this one we're getting the sum. The sum means because every state have a different land cover type within that state, right? So every land cover type is going to have an area. So basically what we're doing here is to figure out the land cover composition of every state. So again, one line of code, and the denominator here is basically, because this is a 30-meter resolution, the area will be square meter. Because we're doing by state, the number is pretty big, so divided by a million, basically turning from square meter to square kilometer. So they basically get the area in square kilometer, and how many decimal places you want to keep. For example, 1.23 square kilometers, something like that. So run this one and see how long it's going to take. Again, this image is several gigabytes. And you can download it from the USGS, and then you can do the computation by yourself using ArcGIS, and you will see how long it's going to take. Certainly it's going to be much slower than this one. Although right now it's taking a couple seconds, but again, you can do it anywhere. You can do it by county, or you can do it just for all the counties in Indiana. So if you're working in the government, you're trying to figure out which county has the largest contribution to agriculture or water or anything. You just pass in the polygon, give me the data layer, and then you get the result. So now we have this NLCD stats. Now refresh and double click. See that? So class 81, let's do class, what is class 81? You do need to come back to here to see that. Class 81 is pasture and hay, right? Class 71, so what we're looking at is class 82. So I asked about agriculture. So you need to look into this column. This column shows you the agricultural area, crop area for each state. So if you scroll down, this is not ranked, not order alphabetically, but I can do the same thing here. I just get to the result and add a new code block, and then gmap.csv to df, and then I'm going to pass in the NLCD statistic files, and then I can just sort the value. Okay, I'm going to do it by what's the name of the column? Class 82 again. So where is it? It'll be class 82. Oops, no, 83. So class 82 is agriculture. What's the problem? Oh, sort values. No, sort the values. And see, so now I have this sorted by class 82. So we are looking at the largest one. So we need to basically, you can go to the bottom, or you can do it in here to what's that? Ascending equal to false. So that means descending. So in that way, you want to get the largest one. So come back to here, 82. So this one, 107,288 square kilometers. Which one it is? Iowa. Good guess. Yeah, Iowa, Kansas, North Dakota, Illinois, Minnesota. And you can do the same thing to any other lane cover. For example, which state has the largest? How about open water, for example? Right, then you'll be number 11. So what you need to do is just change it here. This one, number 11, and then run it. So which one is the largest open water? I don't see it yet. Yeah, because grade here is counting, so probably it's here. So we can try it, right? And look at it. Michigan. And then Wisconsin, right? So it's very flexible. So it helps you answer question very quickly and just change a little bit, then you get the result. So this is one way of doing the zonal statistics. And next questions, same question, similar. I want to ask which US state has the largest percentage of agricultural area compared to its state area. So for example, Illinois, they say maybe have 70% agriculture. North Dakota, maybe 50%. I want to find out which state has the largest, like in terms of the land cover area, which state has the largest amount of agriculture divided by its land area, basically the percentage, right? So right now we're not talking about absolute. I want to see like the largest composition, like which state has the largest agricultural area compared to its state area. And look at this example here, the source code, again, the same source code, same line of code, except earlier we're using the sum, right now using the percentage. So the percentage, you're getting the percentage for different land cover. So now you run it again, you should get very much similar, but right now we're using this different table. So then I can come here, copy this new same line of code, and I can show you the result. And so this time we're using the NLCD stats. Oh, it's the same thing. So it's running the computation, get the result, and then download it as a CSV. Now we're reading as the CSV. So this one here, we're doing the same thing, looking at agriculture, 82. And look at this, 50, 82, right? 73%. Which US state has the land cover has 70% of that actually is agriculture? Is it Iowa again? Where is it? Yeah, Iowa again. Illinois, Indiana. Indiana right now is top 3. Earlier, in terms of absolute area, it's not. But now if you divide it by land area, so it's moving up a little bit, right? So what's the land cover, the agriculture area? Indiana, is it 82, right? 58%. 58% of US, the Indiana state area is agriculture. Right? So if you come back to here, you can probably see the map here. Yeah, it's pretty close, right? A little bit more than half. And as you can see here, you can get precise results, very accurate, rather than you have to guess. And you can do this kind of simple statistics just with couple lines of code without having to download data. So next time, if you're trying to get some overview of what's available in your state, how many land cover, land use, what's the forest area, urban, water, yeah, just run this one, and then you can do it at a global scale. It doesn't matter. All you need is just a raster or vector, and the methodology, mechanism is the same. Questions? Simple and easy, right? So next, let's do another zonal statistics. So earlier we took in a raster and a vector. And the raster, the first one is basically DM, continuous data, and vector data. The second one is categorical data and vector data. So the land cover. Next one I'm going to do is 2 images. So let's see what this one is about. So I'm loading a DM. And then, what time is it? Okay, let's finish this one. Okay. And then we're going to load the land cover. Okay, so I have 2 raster data layers. So what answers can we, what question can we answer in this case? So I have the DM, or I have the land cover, and I'm going to ask you a question. Which land cover type has the largest mean elevation. Basically, which land cover type is at the top, the high altitude area. Now, based on all the land cover type in here. Ice, right? We can pick out, right? So look at all the carbon in here. Or we can ask which land cover type has the lowest mean elevation. So in this way, it's not a vector anymore. It's like you have this categorical raster data, you have the DM, then you need to basically have every category and then calculate the mean elevation. Get the water, calculate the mean elevation for water, get the forest, get to this one, right? I'm asking you the mean. I can also ask which land cover type has the largest standard deviation in terms of elevation. Then basically it's like which land cover type is like up and down, very rocky terrain, on rocky terrain. So you can answer these kind of questions easily using the same zonal statistics. Image, this one is image state by zone. So you're going to give me a DM, give me a land cover type, and the reducer saying the mean, and then you can run it. So behind the scene, you see, we have different classes, and you can look at the statistics. So basically the mean. So earlier I asked about the highest mean elevation. Which one? Number 12, right? 2057. So what is that? 12? Granular ice and snow. The reason for that is because those are usually in the mountainous region, very high elevation. So only a small percentage. You might not see clearly, but this is like very high. This is why they have snow and ice. But certainly you can also see like which one has the lowest. 164. And actually this one, 162. Is it? So number 90. What is number 90? Woody wetlands. Okay, very long. It's hard to guess, right? You can verify it. You can actually see all the temperature, elevation there if you want to. So this can help you answer questions for any 2 images. And then you can save the result if you want to. And the last one I'm showing here is standard deviation. So earlier we used the mean, now we're using the standard deviation. That means which land cover, the elevation within this land cover type is like up and down, is a lot of differences. And same thing here, I can just, save as the CSV. And, if you don't save as a CSV, it will return a data frame. So they can see the data frame directly in here. And now let's see which one. You can sort the values and to make it easier if you want to. So I can just say here dot sort values, and then this column will be the stats column, and then you'll be ascending equal to false. That means it's going to be descending. So okay, number 42, 967. What's number 42? Okay, evergreen forest. It makes sense because forest can grow in different altitudes. All right, so this is about some of the zonal statistics. You see, this is real power of using cloud computing analytics. No download data, one line of code, get analysis very, very quickly. And you can just imagine one image, one vector, continuous image, discrete, categorical data, one vector, or 2 images. And then you can start doing all kind of computation. You can calculate what's the water area, what's the forest area, agriculture, what you name it. And it can be temperature, it can be NDVI, it can be anything you want to calculate. Okay, so let's have a 10 minutes break, and then we come back at 2:20. Okay. All right, let's continue. In the next section, we're going to briefly cover map algebra. So this is useful if you need to calculate some spectral indices, and it's very common in remote sensing. You want to calculate NDVI, normalized difference space station index, or water index, building index, snow index, whatever you like. It's just involving different band combinations. So Here, first let's load this data set, run it, and then let's take a look at the result first before I explain what this one is doing. So here, this is the so-called NDVI, and we are loading the data set. So this is the original one, is just the Landsat data, the Landsat image that we have been using as an example earlier. And so this is how we calculate the NDVI. Look at this one. It looks quite complicated, but there's also another function that we can use to, it's a shortcut. So what this one is doing here is, this is Landsat, for example, this imagery. We select B4. B4 is the near infrared. So the equation will be near infrared minus red band, parentheses, divided by near infrared plus red band, right? Make sense? And then the result will be from negative to -1 to +1. So what we're doing here, it will be select B4 near infrared minus B3 divided by B4 plus B3 parentheses. It looks very lengthy, but this makes it flexible, so you can do all kind of mathematical equations. And this is why it's called map algebra, is to multiply, divide, plus something like that. And you see now we have this NDVI from the original image. But if you want the easiest way, would be like this. So this one, what we're doing here is equivalent to, let me show you the other function here, NDVI 1999 equal to the original Landsat image 1999 dot, and there's a function called normalized. Okay? It doesn't show up, but there's a function called normalized difference. So let me show you here, where does it come from. Go to the documentation, it will be normalized, blah blah, normalized, MORML. This one, image to normalized difference. And this function allows you to provide a list of bank names. And so the normalized difference, it might be difficult to remember, but I can come back to here. And then Landsat 9, normalized difference, and then parentheses. Within there, I can have a list. Then you'll be B4, and then the other one will be B3. So these two should be the same, except the first one is more customizable. If you are not doing like standard normalized difference index, then you need to have subject, minus, plus, whatever. So right now, I can come out this one, and then use this one. Ideally, it should be the same result, you see? Same thing. So if you're just dealing with two bands, B4 minus B3 parentheses divided by B4 plus B3, then you can use this one to calculate the index. And this is the same as remote sensing spectral indices. And simple and easy, just one line of code, you can get that done. You can also do it this way. So I'm calculating, for example, the EVI, Enhanced Vegetation Index. And this one, you're probably more familiar with this equation, right? A number and then plus, minus. And so the first one is the equation. The second parameter is the dictionary. So when it's doing for NIR, it's going to NIR equal to image.select band, something like that. Very much similar to ArcGIS. If you ever use the ArcGIS raster calculator in the old days, I'm not sure what's the name right now for the raster calculator for ArcGIS Pro. I haven't used ArcGIS Pro for many years, but the same thing. You double click the main name and then you write the equation. Same thing in here. So you can write the equation, and then for each symbol, you're going to define what that symbol means. So that symbol is equal to the bank B4, B3, something like that. And this is how you calculate those indices. Run again, you see I get the result. So this is only one image for covering, for example, the Bay Area. And image to expression. Expression means you can write an equation and then define what each symbol means, and then you get the result, and then you load the data, you load the color bar. As simple as that. So it's up to you what indices you want to calculate. You just need to define the equation, and each symbol is corresponding to one of the spectral bands, and then you can use this to calculate it. Okay, so that's about some of the zonal statistics and also the raster calculator. And this is only a tiny, maybe 0.001% of computing power of Google Sensing. They are not more. But I'm showing you the simplest one, that GMap integrated and makes it easy. You might see, for example, all the zonal statistics function looks pretty simple, only one line of code, but under the hood is actually many lines of code. So for those of you who are really want to do, for example, see how it's doing things behind the scene, I can show you if you want to see the function source code. So if you just go to GMap, and then here you can source any function. For example, zonal, let's say zonal states, for example, by group, for example, right? I can come here, I can search, I can find a function. It should show you all the documentation, all the function parameters. And this is where you see the source code. You scroll down, this table is basically all the function parameters. Every function that we're using so far, you can find the documentation on here. And if you really want what's behind the scene, the source code, you can click this, the arrow here. And let's scroll down, see what's the source code used to calculate the CSV. Right? How many lines of code? It's probably maybe 1 to 200, but now it's one line of code. So if you want to do that in JavaScript, you need to write this many lines of code. In GMap, it's already simplified, so this one is so much easier. But if you want to see behind the scene, you can look at this. Kind of like in desktop.js, they have all the toolboxes. You don't know what they do in the toolboxes because if it's not open source, you cannot see the source code. This you can see the source code. If something goes wrong, I can fix it. So if you run into any issues, you report the bug on the GitHub, then we can fix it right away. So this is about some zonal statistics. And again, there's an exercise in here. We don't have time. It's your homework after the workshop, so you can try it out. If you need sample solutions, you can contact me after that. So next, I want to show you some way to work with local data. So earlier, I already showed you how to convert, for example, some vector data from local to the cloud. But now I'm also going to show you basically how you not just vector, you can also do raster. So GMap basically can help you visualize data in the cloud, but you can also visualize data locally. So either basically you can visualize all kind of geospatial data. And kind of like you want to watch a movie, you can watch on Netflix and YouTube, or you can open an MP4 on your computer. You can also watch it. So GMap can help you do all those things. So first, let's download a simple imagery. And in order to run this one, you need to run install those dependencies. So if you run into any issues, you can go back to the beginning. At the top here, I think install GMap or something like that. So from here, you can uncomment it, you can install it. If you haven't run this one before, you might run into dependency issues. Just uncomment, Control Enter, run all the packages, restart the kernel, and then it should work. So let me go back to the local data in here. And so we already downloaded a simple SRTM. So look at this function here, gmap.map, right? We already know this one. The difference from the Google Sensing, like map.add layer, is to add Google Sensing data layer. Map.add raster is to add local raster. So, and then you can do the same thing, visualization, add a color bar, everything else should be pretty much similar. So let's see, oops. Okay, local type server is not installed. Okay, then I have to install it. So again, let me go back to here. Install GMap. I believe I already installed, but local type server. And just make sure if this. Okay, yeah, it's not installed, so I didn't install it yet. Just run this one. And I believe local type server is in the GMap workshop. If it doesn't, then you just type this local type server, LOCALTILESERVER. Just install it. So hopefully it works. If you don't see any error messages, then we are good to go. You see there are tons of packages. Right? So after install, then you can restart the kernel. Restart kernel and clear all outputs. Restart the kernel. And clear all output sales. Then you need to authenticate again. Run it. Alright, so let me go back to this one. Hopefully it works now. Single band. You don't need to download again and run this one. All right, so I see the map. If you see any error message, then probably the dependency is not installed. You just install it, then it should work. Can you see the DM? Anyone? No? Not working? In Google Colab, it might be a little bit slower. I think it's like zooming like slowly, gradually. This is why running local is much more smooth. Because the Thai server, the local Thai server on Google Colab basically is creating another server to render the tiles. So it's a little bit laggy. It might be, you might see the spinning, keep spinning. That's normal. But if you want better performance, you need to set it up on a local computer. So for me, it's pretty smooth. Right? It's still spinning. Basically the same thing. It's downloading all the tiles. And this one here, this image is not Google Earth Engine, okay? This one is locally. Even if you are in Google Colab, that file is in Google Colab is still considered a local file. And I can come here. I can turn the layer on off. I can change the opacity. Oops. I can change it. So this is local raster data layer. Again, you cannot use this data layer for computation with Google Earth Engine. There are two different worlds, okay? One is on the ground, the other one is in the sky. They are different, but you can load them at the same map, on the same map that you can compare different data layers, okay? You can download another one, for example here. This one is a kind of a optical data, multispectral bands, right? Same thing in here. You should be able to visualize that using the same mechanism. Oops. Right, turn on and off, and you can change the band combination. So in this is 4, 1, 2, right? You'll be, what is one? Oh, one red, green, and blue, and then near infrared. So I can do it 1, 2, 3. 1, 2, 3 is RGB, okay? And if I want it, you should see a different color. So in, like I said, in Google Colab, it's zooming to the images very slowly. It's because of the Google Colab limitation. Okay, so right now we're using the natural color composite, and you can also visualize vector data. So again, we're downloading a GeoJSON from the internet, and then we can use the function called add GeoJSON. Again, this is local data, nothing in the cloud, but you can convert this one to Google Earth Engine feature collection using the GeoJSON to EE, then you will turn into cloud. But for this one right now, we're just using local data set. So you can zoom in, you can zoom out, you can hover your mouse, you will be able to see low right here, you're going to see the attribute. So if you change so it's automatic. You can also change the color. This looks a little bit complicated. This is how the data are being visualized. So these are all the undersea cable, internet cable across the oceans. And this is why we have internet here. It's coming from somewhere. So, and this is here, if you hover your mouse, you'll be able to see the map. So pretty cool. A couple of lines of code, you can create some visualization to visualize line, polygons, points, or something like that. You have all the source code. You can digest the source code. We don't have time to go into the details. But when you see the map, you see what it looks like. If you have a similar data set, you just go back and then just change the input data, and then everything else pretty much remain the same. You can also, for example, add country, add GeoJSON. So basically, just remember, create a map. If it is from Google Earth Engine, you'll be map.add layer, add underscore layer. If it's local data, you have two functions. Map.add raster is add local raster. Map.add GeoJSON, add GeoJSON. Map.add HSP, map.add GDF. Basically, those similar functions that we used earlier. So this one is add GeoJSON, different color in here. We also have, you can have a random color if you want to. So it's a bit more complicated. And next one, yeah, it's still all add GeoJSON. Okay, you can change the color, for example. You will see the visualization is very flexible. Similar to Google Earth Engine when you customize the color, hex code, something like that. So here is very much similar. So when I hover my mouse, you see, it changes the color to darker color. So everything can be controlled in here. And you might be familiar, right? Hex color code. So 0, 0, 0, FF, right? Red, green, blue. This is why it's blue color. So how do we change to yellow color? Yellow boundary. What's the yellow color? Hex color code. So which two color combined become yellow? So it'd be red and green, right? So fully red and fully green becomes yellow. So it'd be FF, 0, 0. So this will be red color. Let's see. Okay, you have red color. Hover my mouse. Okay. Red, green, blue. You can just Google yellow color hex code. You will find out whatever a cyan color, for example, right? So yellow color hex code, right? FF00, or it can be maybe cyan color. If you don't know, every color has a hex color code. CYAN, right? 0FFFF. Okay, so you can customize it or whatever you want. And also this one here, the line and also the fill color. The fill color, this one is blue color, right? 000FF. So it's blue color, and the fill opacity originally is 0.1, 10%. And if you hover your mouse, it becomes 70%. So that's why when I hover my mouse, see here. You can also change it. For example, right now it's yellow color, and then when you hover your mouse, you want to change to red color. You can do that as well. So I can come into here, comma, and then what I need to do is just color, and then colon. So this will be, what's the hex code for red color? FF0000, right? Simple. So run this one. Now take a look. So originally it's red, yellow color, right? When I hover my mouse, see, red color, and then fill with blue color. Right? It's simple, very simple. So just make sure you have the style is when you originally load it, what you want it to look like. The hover style is when you hover your mouse to a polygon, what you want to change. So you can just make adjustment. It looks very complicated, but you can use desktop GIS if you know how to do that, but desktop GIS is not this flexible. You can see, you can click, but I don't think ArcGIS allows you to hover and then change the color easily. You might need to do some coding, I don't know. But programming is fun because you have precise control about exactly what you want, different color. So that's about GeoJSON, but you can also do shape file. I'm downloading a sample shape file, and then just use map.xsp. And you see the same vector data, and also you can do geodata frame, add GDF. You will add a geodata frame. So basically GMap can handle visualization for all kind of vector data. If you forget which one to use, you can just use the simple one, map.add_vector. That's it. So you don't have to worry about it's a GeoJSON, it's a swap file, or it's a GeoPackage, or map.add_vector or map.add_raster. And you can just render all kind of vector and raster data. Or GeoPackage, for example, right? This is why I actually use the add vector in here. So you can render a GeoPackage. So under the hood is using GeoPandas to read any vector data, and then just turn that geodata frame into a GeoJSON, and add a GeoJSON to the map. Okay, but keep it in mind, this is good for small data set. If your vector data is 100 megabyte or 1 gigabyte, don't try to do this because it's loading all the data to the map. So your map will become very laggy. So good for small data set, not good for large data set. So if it is really big, the recommended way is to upload your data to Google Engine, and then it become a feature collection. Then it doesn't matter how big is the data set. It can be gigabyte, it can be terabyte, it doesn't matter. It's still very fast because when you zoom in and zoom out, it's only requesting a small subset of the data set. And so that's about visualizing some vector data, GeoJSON, shapefile, GeoPackage, GeoPanda data, geodata frame, or GeoPackage. So next, a little bit more functionality here to help you do some conversion. So imagine you might have some location data with latitude, longitude, even field survey or anything. So I'm just downloading a sample data set of US cities, and then it has 2 columns. This is just CSV, so it's not vector data. And then you have longitude, latitude. So if you use ArcGIS, I think there's a function tool called XY data, something like that, or convert the XY to vector data. So we have these two columns, and GMap has similar functionality, CSV to GeoJSON. And just tell me what column is the latitude, what column is the latitude and longitude, and then you can save this one as a GeoJSON and just run it. You see, very quick. So now you should have these cities .geojson somewhere on your Google Drive. Oops, cities. Where is it? Run this one. Do I have that? Oh, here, the first one. Okay. So this is converted from the CSV to GeoJSON. Basically, it's from tabular data to vector data. And then you can visualize it. I can also CSV to shape file. So basically, anytime you have two columns of latitude, longitude, then you can save it, right? So now I have this cities in shape file, or you can convert to any vector data geo package, for example. You can convert to a geodata frame, something like that. So now you have this column of geometry, and then you can use that to do visualization. So for example, once you have this one, this is a geodata frame, then you can use gdf.explore. So this is a geodata frame function, and then you can visualize the data, right? All the points, all the cities in the US. So when you hover a mouse, you'll be able to see that. And this is just a simple way to turn tabular data to vector data. Or you can use this way, the same line of code, and then create a map, and then there's a function called add points from XY. Again, I steal the name from ArcGIS. They had two boxes called points from XY, something like that. So you don't need to download the data. You will download the data under the hood. And with one line of code, I'm adding the city CSV because it has a latitude, longitude. And then I'll just specify which column is longitude, which one is latitude. And look at this. Pretty nice, right? It's a marker cluster. You might have seen some of this on the internet. Looks very fancy, but it's one line of code. Right? So here, zoom in, zoom out, click that. You see this one? Right? Pretty cool. Just add points from XY. And there's passing the file path. It can be a file on a local computer, or it can be a file from the internet, as long as you have the direct URL, right? So, or I can remove this one because I already downloaded I have the file, for example, US cities.csv, right? For example, here, you can add from locally. So I can just do this one, US cities.csv. It should be the same result. Very quick and responsive. And now you can just enjoy the web mapping. This is using leaflet under the hood, so it's pretty simple. One line of code with some fancy maps. You can also do vector. So let's see this one more time. Add point from XY. So you can also have something like this. This is even cooler. You see the spinning icon. Different region, for example, different region I can add a different icon. So I have 4 regions: west, mid, west, south, and northeast. So each region I can add. Basically, when you add the data, you can use different icons. So sometimes if you want to make it a little bit more fancy, you can. So basically, the function has a lot of parameters that you can customize. The same thing, I'm adding this CSV, and then I have different the latitude, longitude column. You can say which column you want to use to color the points, because the CSV, for example, here we click this one, it's the region called south, right? Region called west. So you can get the location. You can also use a column to do the coloring, and this is why you can have this. And you can also specify what icon you want to use: gear, map, leaf, globe, all kind of icons. And you might be wondering, how do I know these are the name of the icon? I want to choose something else. Yeah, you can do that as well. So if you really want it, you can Google it, called awesome icon. I think the version is like 5.7 or something. Not the latest one, but you can just try awesome icon, and then Just click it. And here you'll be able to find all the icons. So the name available here, you'll be available in there. So for example, how about this one? Okay, I like the webcam. I know the name here is called webcam. Then you can go back to here. You can change it. For example, for the globe, I can change it to webcam. Hopefully it works. Where's the webcam? Be this one, right? Oh, it doesn't render. It's so probably this is a newer version. It's too new, so some of those doesn't work. But how about, I think, and phone awesome. Yeah. So maybe I think there's one called home, I believe. Let me see again. Yeah, this one works, right? See the home spinning, right? So this is Google font awesome. And you'll be able to find, but I think it's an older version, so not all of those are supported. If it doesn't show up, you just change to another one, then you have a lot of these to choose from. So makes it really, really flexible. And again, one line of code, you can do a lot of things. Create some nice maps, add some data, and also add a legend. And whether you want to spin or not. So if you don't want it to spin, then you just change it to false. Then you just be static. Right, so now it doesn't spin anymore. So this is add data from XYZ, and the other one is X circle markers. So sometimes you just want a simple points. You don't want to mark a cluster, then you can use this one. Circle marker from XY. And again, those color here, those parameters are pretty straightforward. You can customize the color and you can click it. You can also see the pop-up from there. Questions? Okay, so that's about the vector data. So next section about raster data. So we have talked about image collection in the cloud, but we also have a lot of data not in the Google Sensing Cloud. So you might have data locally, or you might have data on AWS, you might have data on Microsoft, you might have data on GitHub, or you might have data, whatever you host the data, but it's publicly accessible. You can also use Gmap to load the data. So this one, the function here is called add cog layer. Add cog layer means add cloud optimized GeoTIFF layer. And you want to have this URL here. So this URL is pointing to, for example, data from MaxR. So it's a high resolution raster data layer. And you see this image itself, I think it's 2 GB, but I load it in seconds. But this one is not in the Google Sensing, okay, it's in the cloud. If you want to see it, so make sure if you find any images and then you get a direct URL to the image, you can use Gmap to visualize that. So let me Control C just to show you where it did come from. Control C and then Control V. And let me hit enter. Usually it's a pop-up. So when you get the URL, if you paste into the browser, it should pop up this one, asking you to download. That means it's a direct URL. If it opens up a new web page, there's no a direct URL. You cannot use that to load it. So if I try to save it, see how long it's going to take. 15 minutes. 2.9 GB. I don't want it. Just cancel it. But you see, I load the 2.9 GB pretty easily. And the reason for that is the same mechanism that I showed you earlier. It's not downloading the entire 2.9 GB. When I'm zooming in, you see this nice resolution, but the area is pretty small. When I zoom out, it's a lower resolution. So it's downloading the tiles on the fly. That's why we use the so-called cloud optimized GeoTIFF. It allows you to retrieve the data on demand using the HTTP range request. And same thing, if you want to try it out, for example, go to here, and I can go to the set more tools, developer tools, and look at this one. So, right, if I zoom in, you see that it's loading the tiles and loading this. So, where is it? So if I double click, this one is not showing up. Probably need to find another one. Oh, this is just the base map, but the imagery is the same thing. So it's downloading a bunch of PNG tiles from the server. And so this is one, but I can have another example here. So you can also use the function called cog center. So it allows you to basically calculate. So you have a bunch of images, for example, in the cloud. This is one of those. and you can use it to request, for example, what's the centroid of this image. This function shows you the centroid, how many bands within the image, B1, B2, B3. You can also, for example, this is before the file, and this one is after the file, wire file. You can zoom in. So right now I have two data layers in here, one on the on top, the other one at the bottom, and you can use the toolbar here to turn the layer on and off. Right. So this is before, this is after the file, and you can check this. You can see the changes. So this is one way you can visualize the data. And the next one here, this one is even better, the split map. Okay, the split map allows you to change the data layer side by side like this. Yes? No, this is just one. You can add as many as you want. Yes, yeah, it should also be able to handle that. You can also have a virtual mosaic. So if you have a virtual mosaic, Gmap can also pull the virtual mosaic. For example, you might have a bunch of cloud optimized geotiff for the state of Indiana. You will pull the entire cloud optimized geotiff. It's a single file. So I have some of the files in here. I'm not sure if you let me see if it works. Here, let me go to my Open Geospatial. So this is all the packages they have. And I believe I have a MaxR, for example, MaxR open data. And I retrieve all the data here, all the data set. So for example, these are all the data set available. And I can, for example, go into Morocco earthquake. And if you look in the GeoJSON, for example, these are all the files, like all the smaller tiles, all the images for captured by MaxR, but I can visualize this entire mosaic all at once. So all you need to do here is, I forgot what I did. I think it's this JSON file. And so all I need to do is just double click, copy the link, and you see here, this is called mosaic JSON. Mosaic JSON, basically, it's already mosaicing all the images all together. Then I can come back to here. Let me see if it works. No guarantee, okay? This is the danger of like doing demo on the fly, but let's try. So gmap.map, and then you'll be m.add. Let me run this one here. Oops. The new one. So this one is using the map.add. It's called stack layer, spatial temporal asset catalog data layer. And let's try it. So the URL, we need to get the URL first. Okay, so URL equal to this one. Okay, and then just URL. I'm not sure if it works or not. Oops. Tiles, blah blah, endpoint. I believe this should work. I have done that before, so let me look at this source code. I actually have a web app that allows you to visualize all the data, and it's called Solara MaxR here. And then, for example, the earthquake. Right, so these are all the images. Actually, it's collected by MaxR, and you can go anywhere. If I click some of those, you should be able to load the images. So definitely, it may be just Gmap, but I'm showing here. This image you see is just one, but actually it's a lot of smaller tiles composite together. So it certainly should be able to do that. I can look at the source code, see how I did it. I forgot how I did it a long time ago, but it should be very much similar. So get the JSON, get the image tag, get the widget. There should be a function called add stack layer or something like that. Split map. Yeah, it's X stack layer, and then the name, bit bounds, the mosaic, the URL, the dataset, the JSON file. Yeah, it should be. So it might be just Gmap, but let me change to leaf map. import leaf map, and then extract layer. Oh, interesting. Something must be URL dataset variables geospatial. Anyway, I will fix it during the break. It should work. Something is missing. I will look into that. And so here, the next one is the spatial temporal asset catalog. So it's very much similar. You can get the images, get the bound, and then so here, this is another image, for example, covering Canada. So we have two data layers, and it's from the cloud. You don't necessarily have to have the data in Google Engine. So Gmail can help you visualize data from all kind of places. And stacked, if you're not familiar, it stands for Spatial Temporal Asset Catalog. So basically a new protocol, a new standard used to creating a catalog for geospatial data. And then you can easily search and query the data, and then you can get the results and you pass into your program. Right, so let's cover a little bit more about exporting data, and then we can have another break. So assume that you have know how to visualize the data, you know how to do some calculation, and we also talk about how to visualize some local data. So by now you should understand, right now if I give you any raster data, any vector data, either it's locally or in the cloud, you should be able to visualize that, right? Add layer, add raster, add vector, add hog layer, add stack layer. There's only a couple functions that you need to remember. Then you just need to figure out what visualization parameters you want to customize. And after you have done some visualization, or after you have filtered images, and assume that, okay, I want to get the data out from Google Engine. How do I do that? So there are different ways you can get the data. You can get smaller amount of data, or you can get large amount of data. Depends on the volume of the data. There are different ways you can do it. So first, let's look at this sample image. Okay, so this is just one landscape image covering San Francisco, and you can export the entire image, or you can export just a small area. So for example, I create a rectangle. I just want image for this small area. And one thing to keep in mind is, if the data set is pretty small, you can download it right away to your computer. If the data set is pretty big, you need to wait, okay? It's a free resource. Just like think about it's a theater, right? It's open for everyone. All want to go to watch the movie. You need to wait in line, okay? There's only the bandwidth is limited. So if you're getting large amount of data, you need to wait and take some time. But small amount of data, you can get it right away. So here, look at this small area, and the function you need to use is this one, export image, and then passing the image object. So we are having this image, this landscape image. I'm going to output it, save it as landscape.tif, scale 30 meter, and the region. So for all the images, you don't have to download the entire image. You can specify just the region. So think about, you have a global scale image. It's just one image for Indiana. You can still point into that global image and then specify all the parameters, and the last one, region. You can pass in the Indiana region, the geometry, and then you will download just Indiana. So run this one, and you see it's going to generate the URL, and then you could download the data. So this generally is good for a small data set that you want to get it right away. And landscape.tif, now you should have this one directly on your computer. Here, landscape.tif. So now I get the data. It's pretty small, only a couple megabytes. So the rule of thumb is like, if your image is many gigabytes, you won't be able to download directly. Google's engine does not allow that. And sometimes you want to customize the projection. For example, you might want to download time series images. Use the e-to-export image. By default, you don't need to specify the CIS and also the CIS transform. But if you're trying to download some multiple images for the same area, sometimes you might notice you download one image, you download another one, there's a slightly half pixel offset. It doesn't align perfectly well. Then in that case, you want to specify these two parameters, CIS and CIS transform. Because if you don't specify, Google saying is going to estimate the base, basically upper left corner Basically, sometimes it might be half pixel offset. So again, if you want to download multiple images, you want to make sure that pixel by pixel is aligned perfectly, then you specify it. Otherwise, you don't have to. So the projection, you see, this is EPSG 3260, something like that. And so you can just use those. If you don't know what it is, you can always Google it. For example, paste. Oops. Projection. Right. And so this one is UTM zone 10 north. Okay. So EPSG is just basically similar to ArcGIS. You open, you see the projection, but we are using the standardized one, the EPSG European Petroleum Standard Group, I believe. Like it's, you can Google it, you'll be able to find all the information about its projection. So you can customize what projection you want to use, and then you can specify projection, something like that, and you should be able to get the data. So in that way, it will perfectly align with each other. So this is the simple way to get the image to your computer directly for a small area. For large data set, you use this one, export image to Google Drive. So that means you need to wait. It's not instant. So if I run this one, okay, it looks instant. It's not done yet. So what this one is doing is send a request to Google Sending, saying that, okay, I want this image for this area, download it to my Google Drive. And it's going to take some time. So if you want to change it, you need to go to your Google Sending account. Again, you will see from here. Gmail doesn't show you the status, but you can go to Google Sending and then log into the account. On the right here, you should see this tab, task. Okay, and then you should see this one right now is running. Usually it should be a minute or two. So this is suitable for large images. For example, if your image is 1 GB, then you're going to send it to Google Sending, and then it's going to download to Google Drive. So in that way, you don't have to keep your computer running. Once this one is sent to the task, it will automatically download to Google Drive. So even if you shut down the computer, you will have the image after it's ready. So now you see the blue one is done. Then I can click the drop down list, open in Drive. And you see, now it's on my Google Drive. It's this one, right? I just downloaded it, not this one. Or it might take some time. So it makes it overwriting the image. So this is March 30, but it should overwrite and then update it. So you can delete it. So you can decide where you want to be exported. So this is under my export directory. It's in here. The reason for that is I ask you to export this to this folder. You can change the name of the folder. You will basically export to whatever folder that you specify. Make sense? So small image, download it locally. Large image, download to Google Drive. And there's one last one here, download e-image. This one is kind of a workaround for Google Sending limitation that allows you to download a large image to your computer directly without using Google Drive. So what it's doing, because Google Sending is limiting you to download, for example, 32 megabytes directly from Google Drive. So this one is downloading 32, cut it into smaller tiles and then mosaic them as a bigger one. So if there's something you want, you can use this one. For example, I'm downloading this in Thailand 16, 90-meter resolution. So this is 79 megabytes. You can download it right away to your computer without having to wait for Google Drive. So this is kind of a hack of Google Sending. It might be blocked in the future, I don't know, but if you want, you can. So for example, you search all the images. Now, oh, this looks good. I want this one right away. Yeah, use this one, download e-image. You will be able to get this one pretty much a couple seconds. It can be, you can change it to 30-meter resolution. It will take a little bit more time, but you will be able to get it. So basically, this entire image, for example, right, this one is 717 megabyte. Is this one I'm showing you here? This entire image, original data. If you want it, you can use this function. Again, it's going to take some time for you to download, but it's faster than you download to Google Drive. Google Drive is going to take some time, and this is basically just a workaround. Use it if you need to, but don't abuse it, because I'm not sure if they block your account or not if you're doing for too much. But from time to time, you should be fine. So this is how you export one image, and just pointing to the image, and just figure out what area do you want, what resolution, what spectral coordinate system, something like that, and you can download it directly. If you don't need the original resolution, you can change the scale. The scale is the resolution. Okay, 30 meter, 90 meter, 60 meter, whatever way you want. So this is downloading just a single image. The next one here, downloading image collection. So imagine you are working in Michigan City, just like what we did earlier, right? We searched all the cloud-free images, 157. You want to download all the images all at once? Yeah, you can. Just one line of code, you can download all the images all at once to your computer. Just doing one line of code. So let's wait for this one to finish, and then we can show you the next section. So basically, you can download image, you can download image collection, you can download feature collection. So 3 different ways to download the data. And after it's finishing up, you see it's blue color, and it takes a couple seconds to change to green because it's mosaicing the image, mosaicing the type as a single image locally. And after that, you should be able to find this one on your computer. In here, I might not be able to. You can open the file explorer to see how big is the file. File, yeah, 392. It's because it's compressed, but the original file size is 718 megabyte. So there's all single image. Next, let me show you here. I'm going to show you, for example, the USDA net imagery 1 meter resolution intersecting this point, right? You can change it to any point. And let's see how many images in there. In total, there are 7 net imagery, right? Similar, if you want to find the USDA imagery for this hotel, you can do that as well. And then just use this one, export image collection. And then just give me the time series image collection. Where do you want to output? If you have a period, that means it's the current directory. And then you can change the scale, right? The resolution original was 1 meter. It's too long, but look at this. It's going to show you in total there are 7 images, and you're just going to download automatically. So it doesn't matter how many images you have. It can be 1, it can be 100, it can be 1,000. The more you have, the longer it's going to take. So, but how nice it is. I can search any images, and I download any amount of images to my computer for free. So now you don't need to go online to search everywhere. USGS, NASA, and trying to download data. You just go to GMap, point to the image collection, find out the area, filter it to the cloud coverage, and then get the image collection. Once you have control to that image collection, you can download it to your computer easily. You can also download to a Google Drive. If the image is too big, then you have to download to a Google Drive. So these have 7 images. You can download it all at once. And this is where the advantage of using Python. If you're a JavaScript user, I'm not sure if you have ever tried to download 100 images using the JavaScript code editor. You need to click the button multiple times, like one image, 1 time, twice. It's very tedious. This is automatic. Run this one line of code. It's going to send the task to Google Engine. And then you see all the tasks coming up in here. And there's no run button. It's automatic. If you use JavaScript, you need to click the button one by one. So if you're exporting 100 images, good luck. You click 100 times. Python is automatic, so you can start the task. So this is why you may want to use Python to do some task exporting. And lastly, it's about vector data. So we're going to show you how to export the vector data. Actually, we already covered it previously, but I just want to reiterate again here. For example, I'm working on Alaska. I want to export this image. So this is the function, right? Earlier when we said get data from local to cloud and from cloud to local, it's the same function. So E to HSP, E to GeoJSON, E to CSV. So this is a function to quickly get the data from the cloud to local computer. If you have a large data set, you need to export to Google Drive. So if your vector data is pretty big, for example, you are trying to export all the US road network using the census data for the state of Indiana, that one you cannot download directly. You have to send to Google Drive. So same thing here. These are usually pretty small, so it should be instant. Within a couple seconds, you should be able to convert the data set, right, to CSV, to GDF, to DF, and anything. For example, this last function here, export vector to Drive. So if you're exporting anything to Google Drive, after you run it, you need to check the status on the JavaScript code editor. It's not showing up in Gmap because it's going to take time, because this is finished and this is running. But for the finished one, I can right click and then open Drive. So you should be able to see all the files that I have exported in here on my Google Drive. Okay, so that's all I want to cover here, is exporting the data. And let's have a 10 more minutes break, and then come back. We can deal with some funny animation, like rather than not so funny analysis. So this would be a much more interesting. Okay, so what time is it right now? 3:13. So we come back at 3:23. Okay, and then we have about 40 minutes to finish all the remaining one. Okay, let's continue. So we have 35 minutes left. We probably will not finish all the materials, but like I said, you can try it out yourself. So we will see how far we can go. And the next section is probably the funniest part of the workshop, is that allows you to really create some animation easily using Google Sensing. So you might have seen some of those on the internet, but I'm going to show you how you can create by yourself easily. Accessing any satellite images, any area images, time series images, and then just create an animation to see how things changes on the landscape. So first, let's simply just create a map. For example, here, create a map around Michigan City, or anywhere you like. It doesn't matter, right? So once you have here, I can just simply draw a rectangle somewhere. For example, I can go here, maybe like this. Okay. Don't make too big of an area. The data are going to be volume is pretty big. So try to start with a small area first, and then you can see how far how it looks like, and then run this next code block. So this one basically is telling Google, saying, you said, if you don't draw an ROI, I'm going to use the default ROI here, the bounding boxes. If you draw the one, you're going to use the one that you draw, and then just call this function gmap.lengthset timelapse. Just one line of code, and you can change the name. So this would be, for example, Michigan City and GF, and we can have the start year, the end year. So basically, length set, we have images since the 1980s. So length set 5 from 1984. And so what we're trying to do here is create images every year, like 84, 85, 86, all the way to 2023. And you can use the start and end date, means I only want to use the images from the summer. Okay, June, July, August. And then I'm going to use the band combination of the short wave, near infrared, red band, frame per second. Basically, let me run this first. Okay, frame per second means how many frames you want to have within 1 second. The larger the number, the faster the animation. And you can have a title, you can have a progress bar, and also whether you want to convert this one to an MP4 or not. So we have a couple seconds. Okay, now I have an animation. Of course, Michigan City doesn't change that much, so it's not very. But at least you see the coast. Here the coast change, coastal erosion. The same bar. See here. You can zoom in a little bit to see, right? And look how nice it is. 20-30 seconds, you get the animation, and you can do it for anywhere, any location. And it's automatically aggregating all the landscape images from the 1980s to nowadays, right? So you're going to end up with over 40 images. And it can be by month, you can do it by quarter, you can do it by week, as long as your time series supports that. And you might look simple, but under the hood, it's processing all the images covering Michigan City throughout the years. And then it's removing the cloud, creating a cloud free, and generating this animation. So this takes you 20-30 seconds without Google Sensing or cloud computing. If I'm asking you to go to USGS Explorer to download data and then do it by yourself, creating one, I can guarantee you this takes you hours. Because you need to figure out the images, you need to clip to them, and you need to figure out pick up the base images, and then they're always going to have cloud. Pretty much, especially in the coastal, every image is going to have cloud. How do you remove the cloud with a bunch of poor quality images? And this is the magic of using cloud computing, is that you can just do a simple medium filter. You remove all the cloud, and then you can generate these cloud-free images pretty easy. And you're welcome to try out anywhere. So for example, I can zoom to anywhere you like. And I know for example, I know the famous Las Vegas in here, right? Zoom here. And the nice thing about this, I don't need to change any code. It's still on the same source code. So here, I can just draw a rectangle somewhere, zoom to anywhere you like. I want to look at changes in Las Vegas. And that's it. So again, run the code again. And right now I'm changed to Las Vegas. Okay. And the start year, I know it has more images available in the 1980s, or I can start from maybe 1985, for example. So you're going to have images for every year, annually, and let's see. And how long is it going to take? I don't really change a whole lot, right? So the same source code, but you can get images for any location on the globe, and it synthesizes all the Landsat images, because Landsat 5, 7, 8, and 9, they are very different. The sense are different. So basically combining all together, look at this. How long does it take? 20, 30 seconds. You see how it's changing? How cool it is. But you can change the different band combination. You can change it to first color composite. You can change to natural color. It doesn't matter. So this is different from the Google Earth. If you go to, for example, if you go to Google Earth Engine, they also have a time lapse in here. So if you go to the Google Earth Engine website, you click the time lapse. You also have the time lapse for the entire globe. But the downside, this one is only RGB only. It's coarse resolution. You cannot change it to other band combination. But the nice thing, it's global. So similarly, you can zoom to, for example, Las Vegas, or anywhere you like. For example, here, Las Vegas. And it's all cloud-free. It's pretty nice. But this is what it looks like. Of course, you can change the color. You can change the visualization. Everything is customizable using Google Engine. So look at this. So try it out any way you like. And the next one here, this one is even better. So this one is allowing to, for example, I right now have this interface. So previously we create the animation, and then it's going to show you this animation in here. You can, it's actually downloaded to your computer. So if you click this one, and then if you refresh it, you should have this animation here on your local computer. You have a GIF, you also have an MP4. So it's automatic. Oops, it doesn't open here in Jupyter Lab, but you can open it on your local computer here. I believe you should have this one, Las Vegas MP4. Open it one. See that? So it can be GIF animation or the MP4 format. And even better, when you create a map, I think it's, let me show you. It'll be like this. So just gmap.map, create a map, display the map. I'm going to show you where the button is coming from, right? So here, if you click the upper right corner here, and there's this button, this kind of globe, create time lapse, and that's it. You have this one here. So now I can zoom to any location you like, and you can start creating the time lapse animation. So here, for example, let me find Las Vegas again. Where is it? Here, right? Look at this. So there's no coding. So you create a map and then create, open the interface. Now I can just do the same thing. I can just come here, draw a rectangle, make like this. And you can specify from 1984 to 2024, how many frames per second. So basically 10 frames per second means 10 images within 1 second. And the year from March to October, and you can change this one. For example, we can just use this one by default, then just create time lapse. You can also calculate the vegetation index or water index or whatever you like. It's up to you. So all the computation will be run when you are requesting this animation. And again, it should be 20-30 seconds. But under the hood is accessing all the images, covering the area, and then process them, removing the cloud, and then create an annual mosaic, and then put all the images together, and then become an animation. Hopefully it works. If your area is too big, sometimes you will say too big. Okay, you see? Nice. And you might see some cloud because some of the images might be, for example, the 2024, they have the images have some cloud, so it's having some problem. And then I can remove it and then clear. Nice thing about this one compared to the previous one is this animation is overlaid on top of the base map. So you can actually zoom in and zoom out. So see here. Right. Of course, it's coarse resolution, so it doesn't look good, but at least you can compare. See here. And I'm not sure we can turn the layer on and off. Yeah, you can also turn it on and off. You can put the animation on top of the base map. So if this is something you want, you can do it this way. Again, all you need is just gmap.map and display the map. Right? You know how to use it. You don't even need to customize anything. So it's very powerful. So you have access to the entire Landsat catalog. So Landsat probably is many petabytes. Landsat 4, 5, 7, and 8, 9. So there are tons of images. And you can do that for any location, any time periods, any band combination, and you can change it to whatever you like. And there are a couple more examples here. For example, this is Las Vegas. I already showed you. The other one is, for example, Hong Kong, right? You can, if you are interested in any area, you just find the bounding box or you draw a rectangle on the map. Then you can see it, right? So next time you're doing some resource anywhere, just look at the images, see how much it changed, right? So this is the Hong Kong airport, and from the what the year? 1990s. See how the urban development or the coastal reclamation, and you can monitor anywhere using these satellite images as long as it can be captured. It's pretty fun, right? You can see changes. You can use different band combination, and so this about Landsat. You can do Sentinel-2 as well. So same thing here. I can create a Sentinel-2 mosaic for Michigan City. Same thing. You can draw a rectangle. If not, you will just use default one. So similar to the Landsat time lapse, this one is using the Sentinel-2 time lapse. Okay, and I highly recommend that you try out anywhere you like, your hometown, even your house. Your house probably you need to use the USDA name imaging 1 meter. Landsat probably cannot see the house clearly, but for large area, a large construction project, you'll be able to see this one easily. And you can go back to the 1980s. So there are tons of data available. And if your area is too big, it might take some time. If your area is small, it should be pretty quick. Okay, let's wait for this one and then see what it looks like. So Sentinel-2 is 10-meter resolution. So it's high resolution data, but again, it doesn't matter. It can be any image, okay? Any image time series. For the common one, I have this dedicated function, but I will show you the other function that you can create some, you see? This one is a short time span, but you can still clearly see some of those coastal erosion and deposition and some agricultural changes. So this is how you can create animations using Landsat and Sentinel. Next one is MODIS. Okay, MODIS is post resolution at a global scale, 1 kilometer resolution. But it's also interesting. You want to see some phenomenon at the global scale. So let's look at this one. Create a map, and I'm going to basically look at the vegetation changes in Africa. And you don't need to change anything. Just NDVI MODIS, NDVI time lapse, and so you can decide which sensor you're going to use. You're going to use Terra or use Aqua. So there are 2 satellite sensors, and what spectral band you're going to use. And look at this. How interesting it is to see the changes throughout the past 2 decades, and see how the phenology changes throughout the years. This is coarse resolution, but you won't be able to see this one using static imagery, right? You can load a bunch of data layer, but this is just so alive. You can see how the Earth is breathing just like humans throughout the years. And you can do that anywhere. Like I said, you can do it for just Indiana, or you can do it for the US. You just need to basically define your area, define your region. Then you can create something like this easily. And again, all the images are downloaded to your Google Drive, to your Google Colab, or your locally. You should be able to have this one, see here. If you double click, you should be able to see the animation, right? Pretty cool. So this is for NDVI. You can also do it for temperature. So if you're studying, for example, climate or weather, you can also create, for example, if you look at the ocean, you can see the temperature changes for the entire globe. And again, there are tons of data being involved just to create this simple animation. But if you do it manually, it's going to take you a lot of time. And the nice thing about this, you can also overlay country boundary on top of that. So this one here, the yellow color, all I need to do is just say overlay color continents, basically the continents, or it can be US states, or it can be countries. So if your area is too big, you want to have some background, you can overlay those vector data on top of that. You also have a color bar at the bottom here, lower right. So you can indicate it, for example, the temperature, the color bar. You can do the same thing for the vegetation if you want to. So all the functions, just look at the parameter. There are a lot of things you can customize to add more things to the map. So that's about MODIS data, like daily. Or next we can, there's another data set from NOAA called GOES, Geostationary Observation Environmental Satellite. This one is like high resolution, not close spatial resolution, but high temporal. That means it gets images every 5 minutes, every couple minutes. So this is good for monitoring natural disasters. And you might have seen this one on the internet. What's this one? The Tonga volcanic eruptions in 2022. And this is something that can capture. So you can see the timestamp in the upper left corner. every 10 minutes, you capture one. And then you have a bunch of images just within a day. So this one just show you almost just 1 day. And you can see the impact of the volcanic eruptions in the area. It's pretty big. See, this is, without this kind of satellite, Landsat, you won't be able to do that because it's only every 2 weeks. Even with 2 satellites, every week, the volcano eruption is lasting a couple hours and it's gone. But with these high tempo frequency images, you can capture it easily. So this can be used to monitor anything, volcanic eruptions, tornadoes, anything happen very, very quickly, or even flooding. But again, this is coarse resolution, so it's not very detailed. It needs to be something happening at a large scale, large regions in order to be able to capture. And you can also do, for example, hurricanes, okay? So next time, if there's any hurricane happening, you know the start and the end day. You just figure out the day here, what's the area, what satellite do you want to use, and then just goes time lapse. It's one line of code. And then just passing the ROI and then the date, then you'll be able to generate the animation easily. And you will see some of this on TV, on social media. Look at this. So you see the black color, this is basically the sunlight and the night. So basically it's rotated, like orbiting the Earth is rotating. So this is look at things very, very far away. So it's capturing the entire globe. So the resolution, spatial resolution is coarse, but it is, this is hurricane evolution. And you can do it anywhere, okay? In whatever region you want to monitor. And next time you see something this on social media, now you know how to create it. You can create one for any area, anytime, any location you like. And not just for visualization. The last one to show you here is actually, these days also have some analysis already built in. So you can monitor wildfire. So not just capturing images, but you can also delineate the wildfire boundary in real time. And these things are actually already integrated into Google Maps. So if you go to Google Maps, if there's any active fire happening somewhere, it will show you the wildfire boundary and also show you how it's changing. So look at this one, right? The wildfire, if you see the pink color, like how the expansion of the wildfire extend, right? So you can do visualization, you can also do analytics all at once. And this is very helpful because when people search and go somewhere, it will show you some of those impacted area. And so this is some of the common one: Landsat, Sentinel, MODIS, and what else? Ghost dataset. But there's a function that you can do for any images, any time series. So if you really want to try it out, I can show you here, gmap.org, and then you can go to the just search this one called create time lapse, and you see this function here. There are a lot of parameters you can customize. So all you need is just give me a collection. I can create a time lapse animation, and you can create by year, by month, by quarter, by week, by day, whatever, as long as your image supports that. And then you can create an animation like this for any area you like. So if you want to try this function, it's pretty powerful. So any time series, it can be temperature, it can be volcanic eruption, it can be anything. It can even be land cover change or something like that. So you can create this pretty easily using this. Okay, so that's the fun part about creating animation. Like I said, try it out using other satellite data, using other region, and get some fun animation that you can share with your friends. And this part is still about mostly visualization. And the last section, we only have 15 minutes. I'll see how far I can go. But last one to show you here, this is also doing a little bit more analytics. You can do forest change, you can do land cover change, you can water change, agriculture change, whatever you want to do. So I'm going to show you some ways you can quickly get some insights about some of these changes. So this example, I'm going to show you the forest change. Okay, we're going to use the global forest change dataset from Matt Hansen, 2000 to 2023. So you get changes every year. So you can figure out, for example, deforestation, or trying to figure out the forest gain or forest loss throughout the years at the global scale. So let's run this couple blocks. We don't have time to get into the details, but I will show you some of the outputs, right? So here I'm showing you 3 data layers. And the last one is the tree cover, but let's start with this one, Landsat 2000. So this is a global mosaic dataset for the entire globe, Landsat 2000. So it has 3 bands, 5, 4, 3. So basically it's just the 4th color composite. So you can see here, 5, 4, 3. And we also have the other one for Landsat 2023. You see it a little bit different because of the background, but and also with the tree cover. So the tree cover is for the year 2000. So basically, based on this Landsat 2000, they did the tree cover. So basically, anything is using a pixel. So any pixel has tree cover more than 10% is being treated as like forest. So you can zoom in to see. You can compare the result to verify it, right? So this is the forest cover, and you can turn the layer on and off, something like that. You can change the opacity, see if it makes. Looks pretty good. You might need to zoom in a little bit more to see how good it is. It's not perfect, okay? Any global data products, when you zoom in, you're going to see a lot of problems. But it's still something that has not been done before, is to develop this kind of global data product. So assume you have Landsat 2000 global scale, you have Landsat 2023 global scale. I delineate the tree cover for 2000, and then I delineate the tree cover for every year, 2000, 2001, all the way to 2023. And then you can see the changes, how many forests has been deforested or new gain. And you can set a threshold. So for this tree cover is basically a percentage. So if you zoom in here, you see the pixel, right? So tree cover basically ranging from 0% to 100%. If you want, you can use the inspector to just see the value, right? Click the inspector, and you can click this pixel. So this one shows you the tree cover. You might turn, let me, too crowded. So let me turn this one off. So this one is 98%. But if you click the darker, lighter color, 55%, right? And you click this one is 42%. So let pixel has 42% is vegetation, and it's we set a threshold, for example, 10%. So that means if the tree cover is less than 10, then we're going to treat it as forest. And then basically we're turning this one into a binary image. So let's run this one again and look at this one. So now we have a new data layer here. And let's see. Tree cover. So now this one is the tree cover. Assume this is the tree cover at the global scale. So you see, just set a simple thresholding. Now I have a tree cover for year 2000. Then you can start doing some analysis. There are a bunch of data layers in here. So basically, the data set has a data layer called loss layer, and it's going to show you. Imagine all the pixels, right, throughout the past 23 years. That pixel is the loss layer going to tell you when it was lost. When was that pixel lost? So for example, if it is 1, that means it's 2001. 2 means it's lost in 2002. So the value is going to range from 0 to 23. So look at this one. So we have a color bar here ranging from 0, yellow one, to the red one. And you can zoom in at the global scale here to see the changes. For example, let's look at the Alaska region here. So what does this mean is yellow means the forest was lost long time ago. In 2020, right? So if it's 0, that means we lost in 2020. And then 2021, 2022, red color means was lost more recently. If this 2020, 23, that means was lost in recent years. So you can see here, and since we're in Indiana, we can see some of those. They're not so much, but you can zoom in to see some of those details in here, right? Something like that. Let's see. Yeah, this does looks is lost, right? It's no longer a forest in here, is it? It become grass or something else. So in the previous year, it might be forest, but now it's gone. If you want, you can look at the inspector here. So lost year 19, that means it was lost in 2019. So this area, the forest was lost in 2019. And again, this are just the data set that's already developed, but we can use the data set to run some analysis. You can also do the forest loss and gain. For example, globally, you can see this, okay? All the red color represent tree loss. All the yellow color represent the gain throughout the year. So within those 2 time periods, you can see if it's something you are trying to figure out the deforestation or the forest gain throughout the years, this would be pretty simple. And it's, again, it's global scale. So you can see the changes throughout the year in the US Southeast, in Alaska, in the West Coast. Looks like Indiana is pretty good. Not much changes throughout the years. And so next, let's quickly run some analysis. How do we figure out aggregate analysis? So I'm going to load the country data layer, all the countries, and I'm going to add this one to the map. Okay. Oops. And after that, we can run some. Oops. Usually have the country. Why the country layer is not showing up? Oh, it's coming up. So the yellow, the blue color here. So the question I can ask would be, which country has the largest forest coverage? You want to guess? Around the globe, which country has most forest? Canada? What else? Right? It's hard to tell, right? It might be a couple countries you have to guess. We can figure it out. Or I can ask, which country has lost the most forest, the largest amount of forest during the last 23 years? Brazil? Okay, we find out, see if this is the answer. And, oh, here I'm just looking at, I think just Alaska, maybe. Yeah, just look at Alaska. Oh, can do it by country, okay. So just look at this one by country and then create a pie chart. Oh, this I think maybe just yeah, this is just looking at Alaska, but you can change it to the whole countries if you want to. So here you can see, for example, which one lost the most forest. So if you really want to, for example, I mean, come back to, all you need to just change, for example, this one right now at the counties in Alaska, but I can change it easily to some countries if you want to, just to show you some ideas. So you can quickly create a pie chart to show in, for example, all these countries. And let me see, US. What is more interesting there? I'll show you by by countries. Okay, so I'm going to here. For the name would be users GSWQS public countries. Not sure if this is the one. Okay, yeah. So now I'm changing it to countries. This is the data set that I have. You can change it to whatever state, countries, whatever polygon, and then doing this way. Okay, so right now you see I'm loading all the countries. So just changing one line of code. Now I can run statistics by country. So what we're doing is the zonal statistics that we covered earlier. You give me one image, length cover. I give another vector data. Then you just run the analysis, and it should be. You can change the scale. So the original data is 30-meter resolution. It's going to take some time. So I change it. If you just want to get rough estimation, you can change it to a large number. Hopefully, it will be done quickly. And once you get the result, then you can figure out, okay, which country has lost the most forest, or which country has the largest amount of forest, or in terms of forest cover, for example, what's the percentage of each country, the composition of the land cover, the forest cover, compared to the global forest cover. And yeah, it's taking a little bit longer time, but let's wait, see if we can get the results. So you can basically create pie chart. You can create a bar plot just to show you the change, show you the statistics. And again, we're just accessing data from the cloud. We don't really download the data. The data set itself is pretty big. Let me see here. Country. Yes, a little bit taking longer than I expected. Anyway, we are almost there. Let's finish this finish this section. Then the last section, for your homework, you can run it and you can try it out. It's about lane cover classification, so it's a little bit more advanced. You want to use the data to do some computation. And the last section is about creating web apps. And again, it's up to you. So let's see if we can get the result now. Okay, it's done. So now this is at a global scale, and let's run this one. See? So I'm running this one at a global scale. All the countries. So which country has the most forest? Russia. And the other one, this is other. So basically, we are only showing the top 20. So if basically all that country combine all together after 20, but I can check this one. You will take this one out. So now it's more clear. Russia, Canada, Brazil, USA, China. You can see all the statistics by country. So this one only shows you basically the forest cover by country. And you can also create a bar plot like this. Right. And again, you can zoom in, you can zoom out, double click. Right. Pretty cool. So give you all the statistics all at once, just one line of code, pretty much. And next one, for example, forest loss. Same thing, zonal statistics. And the tree loss greater than 0, basically, it's, if you have a tree loss, I'm going to aggregate all by the country. And same thing, we can run the statistics to see how it goes. And everything is generated on the fly, right? So we have the original data layer with the forest cover, forest loss, and then we run all the calculations on the statistics based on just those two data layers. It might take 20-30 seconds, but this is still so much faster than you do desktop. You need to download the data maybe, I don't know how big, 100 gigabyte, 30-meter resolution, multiple data layers. It's going to take you some time. Even if you can download it, running zonal statistics using ArcGIS, it's going to take you hours if you're using the 30-meter resolution. This might take you maybe 20-30 seconds, and then you get the result, and you can change it. So it doesn't have to be by country. You can do it, for example, you want to do that for all the counties in Indiana. You just change one line of code, input data, everything else remain the same. Then you get the result just within a couple of seconds. So this is really the real power. Again, we're only showing you a tiny fraction of those cloud computing power and also API. There are a lot more things you can do with this. So hopefully you get this one and then show you the last two plots, then we'll be done for today. So basically we only cover part 1 and part 2. I wish we had 9 hours workshop and show you more, but yeah, the last part you can do it after the workshop and just for fun. Okay, it's done. Now we can create a pie chart. So which country lost the most forest in the past 23 years? Which one? Brazil? Okay, let's review the results. It's actually Russia. And let me turn it off. Russia, Canada, Brazil. Similar. Yeah, US, Indonesia. Again, this is not perfect, okay? Like I told you, global scale, sometimes there's some accuracy problem. You might need to look into the data set. But if you look in the map, earlier that I showed you, this is the global scale map, right? And by country. And if you look at, for example, all the red color is the forest loss. All the yellow color is the forest gain. It does clearly show that Russia has the most red color area. But I didn't produce this data set. I just utilized what they've generated. You can verify it. It has a lot of problems when you zoom in, zoom out, it may be fine, but this is what the data shows. So I'm just aggregating the data to show you the facts. So Russia had lost most forest during the past 23 years. And create a bar plot. This shows you the area, total area, 30 million square kilometer of forest loss from 2000 to 2023. And you can see other countries here. So in terms of loss, I think Brazil has done not very bad compared to Russia and Canada, mostly in the Arctic region because of global warming and climate change. So it probably lost a lot more. Anyway, so that's what I want to show you. We are right about time, 4 o'clock. And like I said, the remaining, it's up to you. You can try it out. And if after you finish all of them, if you want to learn more, then you go to GMap. So here I have tons of more information here. Or you can try out the books. If you go through the book in here, I think today we only cover a little bit, but there are a couple of chapters that we actually didn't cover. So probably I think cover 25% of what the book is about. So you can spend another day or two to learn the real power of cloud computing and how to think about how to apply to solve some problem that you're having. And next time, if you're doing some project, if you want to give yourself your challenge, try to think about how do I do this in Google Search Engine? How do I find the data? What analysis can I do? How do I generate the result? And how much more time it will save you if you use the traditional way. And if you have any questions, if you run into any issues, I recommend you can go to here, the GitHub. This is the best way to ask questions. So go to gmap.org, upper right corner, click the GitHub. And from here, there's a discussion. So if you run into any bugs, you open an issue. If you have questions, you go to discussions. And here, people ask questions all the time, every day. So usually you will get an answer within 24 hours, although it's no guarantee. It's all free labor, so I try my best to answer questions at night when I have time. But you can answer any question here. You can source questions. Any green check mark mainly means it has been answered. If it's not, then you might need to wait. So I hope you learned something new and hope you convince you to use some of this for your work or for your research. And if you have any user cases you want to talk about, see whether it's feasible or not, I will still be here until tomorrow morning. So you're welcome to talk to me and learn more about your work. Thank you very much. And the video will be available after today, so you can go to my YouTube to learn more. So again, the YouTube is here. Let me go to the gmap.org. Where is it? And so on the top page here, you should see the YouTube channel. And all my video, my courses will be all available here. So you're welcome to look at the videos. Over 642 videos available. So you can, not just for Google Search Engine, I also do a lot of other open source stuff. And Google Search Engine right now is my side hustle. So it's not my main one. But you're welcome to go through the video. And I also teach how to build packages. So GMap is I built from scratch. So I also teach courses how to build packages like that from scratch and how to release and how to maintain. So you're welcome to check out. And again, if you have any questions, reach out to me on GitHub or social media. Happy to check with you. Thank you very much.